Imagine a world where cargo ships fly just above water at 300 miles per hour, delivering goods with unmatched speed and efficiency while reshaping global trade and transforming economies. This isn't science fiction. It is the future of maritime transport and defense, surpassing past innovations and launching us into a new era. Hello and welcome to the Hard Tech Podcast. I'm your host, Daniel Apo. I'm a founder of multiple successful hardware tech companies. Today, joining me once again is Riley Knox, CEO and co-founder of Leviathan Air, an autonomous vehicle that utilizes the ground effect and is designed to revolutionize ocean and air freight with cheaper and faster transportation. Riley has a rich background in hardware development, and he has experience founding multiple successful startups. Today's conversation covers Leviathan's technology, aerodynamics, design, and its potential impacts from e-commerce to military applications. Please enjoy. The last time you were here, we were talking about this new idea that you had for, something of a hybrid between a ship and a plane. And you've gone ahead to call it Leviathan. Leviathan is a mythological sea serpent with more than one head. It makes me wonder, what you're doing with your startup and what the name implies. Why did you call it Leviathan Air?
So what it's ultimately doing is building flying cargo ships, so large ground effect vehicles to transport massive amounts of cargo. The name came from when the Soviet Union was building these back in the 60s and 70s. They had two programs going on. There's one that pretty much everybody knows about. There's one that less people know about, that what we're actually kind of basing things off of more. But the one that everyone knows about, it was being built on the Caspian Sea, and the CIA spotted it in satellite images. And it's this giant, 70 meter long, 30 meter wide aircraft, screaming along the surface of the Caspian Sea. They had no idea what it was. They'd never seen anything like it before. And they nicknamed it the Caspian Sea Monster. And so I knew that whatever name that we were going to go with for this company had to be a sea monster based name, as kind of a little tip of the hat to those CIA agents who came up with that name when they spotted it on images. Kraken was already way overused. Okay. Then you had Scylla and Charybdis and a few other ones that are harder to spell, less known, all that stuff. And then Leviathan, which one just sounds really cool and kind of fits with you. When you hear that word, you think gigantic and big things, and these things are going to be huge. But it also wasn't really being used for very much. It's the title of the first book in the Expanse series is Leviathan Wakes. There was a sci-fi movie in the late 80s or early 90s called Leviathan, and then a handful of times then and there. So it was mostly because I was able to get all of the IP and the domains and all that stuff, and it just sounds cool, and it fits with it being a sea monster. So yeah.
Wait, Leviathan.com was available?
No, that not yet. I could have bought it, but it would have been $100,000.
Okay.
But Leviathan Air, Leviathan Cargo, Leviathan Airspace, I snagged half a dozen or a dozen different variations on it, and all of them were available for $8 each or something. Yeah. So it was with a lot of things so far in getting this company going, it was just kind of a fortunate set of circumstances that worked out in our favor. Mm-hmm. Yeah.
I see. We'll get into the topic of the Caspian Sea Monster and the design behind the Leviathan and all that. But I want to set the foundation for the problem, you're trying to solve with this new technology. And it has something to do with transporting cargo. What's the current state of cargo transport vehicles?
Yeah. So right now, if you're wanting to move stuff across oceans, you have exactly two options. You put it on an aircraft and it gets there very fast, and you spend a whole lot of money to do that. Or you put it on a cargo ship. It doesn't cost you nearly as much, but it can take 20 to 40, depending on certain circumstances, 60 days door to door to get it there. So you really have fast and expensive, or you have slow and low cost. The thing is, when you look at moving cargo over land, we have a few other options, because you still have air freight, you still have rail, which are analogous to air and ocean, but you also have trucking in the middle. It's kind of that fills that middle option of speed and cost. And that's really what we're doing with Leviathan, is to kind of fill that gap, because the problem is we've spent the last 60 years optimizing towards those two extremes, but we don't have a middle option that is kind of a balance between speed and cost. It's really, really hard to go fast over water without it costing a whole lot of money. Because if you try and make a ship go a lot faster, you just end up using a whole lot more fuel, because it takes a lot of effort to kind of push your way through water at a higher speed. Even hydrofoils have this issue. You can theoretically fly a plane slower, but the amount that you save in fuel gets offset by the added time of the flight and your operating costs, and the fact that you're not carrying enough cargo. So it ends up costing you more, or it makes it less economical to do it that way. So yeah.
Plus the higher you go, the less fuel you use, and the faster you can go without sacrificing anything else.
Yeah, most aircraft, the way you want to run them is you want to be as high and kind of fast as you can be, because that makes the process more efficient for typical aircraft.
Yeah. That's pretty interesting. Can you quickly summarize what advantages you're pulling from both extremes right now?
Yeah. I mean, so the fun part about ground effect vehicles, especially larger size ones, is it is literally the most efficient way to fly, like to actually be traveling at aircraft speeds. It also means ground effect vehicles benefit from scale. So the bigger you make them, the safer and more efficient they are, because you can be higher off the water surface, which means you can fly over larger waves and still be safe and efficient, which means it's really kind of combining a dramatic increase in tonnage that you can carry compared to an aircraft, while still maintaining that travel speed of an aircraft. So it's balancing out the speed. You're also doing double the efficiency of an aircraft, so burning about half as much fuel per ton, which lends itself more towards how shipping does. Because even though it's slow, it's very, very fuel efficient. It just takes a long time to get anywhere.
Yeah, I mean, you're transporting 15,000 containers at a time.
That's helpful. Yeah. You're spreading out that fuel burn over a whole lot of material.
Yes. Well, that's for a really large vessel anyway. But okay. Do you think this is the right time, you have the right opportunity in front of you because of the increase in demands for goods coming from overseas or being exported, imported?
Yes. On the demand and the economic side, absolutely. That's been ramping up with like Amazon and Shine or Shein, Tumi, things being sold on TikTok and Alibaba and all that stuff. I think when you combine all of those coming out of China, they're currently, last number I saw is they're doing 9,000 or 10,000 tons per day just from those three websites being shipped by air freight. So on the demand side, it like the numbers break your brain when you start to dive into them. There was even the CEO of one of those sites was talking at a Boeing conference in China. It was either earlier this year or late last year. And he was basically saying to them, I don't think you understand. Y'all aren't ready for the e-commerce revolution that's happening right now. And air freight cannot keep up. Y'all aren't building enough of these air freighters fast enough to keep up with what's coming down the pipe.
That's pretty interesting. All right, let's get into the topic of Leviathan Air and what its mission is. What is the overall mission? Let's not talk about technology yet. Just the overall mission and the overall goal. What are you trying to do?
Really, what it comes down to is offering a new way to move large amounts of cargo quickly, cost effectively, and efficiently across oceans. Because the vast majority of how human society interacts and works is the flow of commerce and goods. And 80 or 90% of goods being moved travel over water. So that's the majority of how our global society interacts and conducts business and works with each other, is how we move goods, how we move commerce. And being able to offer an option that, whether you're looking at it coming from the ocean freight side of being able to speed things up, or coming from the air freight side and being able to reduce costs and make things more efficient, having that option of speed, cost effectiveness, and more importantly, efficiency is going to be huge in the future for us. And that's what I really want to make happen. And there's also the benefit of, like, there's a very clear path to us having in the long term, zero CO2 per ton. So basically decarbonizing international air freight using Leviathans.
Yeah.
That's 1% to 2% of global CO2 emissions. So if we can help cut that down, I'd say we'd also done a pretty substantial amount of work on our part to help future generations not cook.
Fine. I'm really interested in how this is going to change everything. But let's talk about you for a sec. Second time founder, am I correct?
Technically, this is my third company.
Third? Okay.
Yeah.
Okay.
Yeah. The first one I started with some buddies in the engineering school at Texas Tech, and we were doing meteorological towers for siting potential locations for wind turbines. But an act of Congress killed that company, which was not fun.
Well, so you started from that. You built Accelerate 3D.
Yep.
And now at this stage of your career, you're like, I want to build the next big thing in transportation. So why did you decide to take on this, idea right now?
Yeah. One, I'm not really good at working on kind of smaller, mundane things. Like, the bigger and more challenging it is, usually the more interesting I find it. Yeah. It's a super cool solution. It's a big, huge problem. It has a gigantic market, and it's something that there are very few people like seriously working on right now.
Yeah.
Mostly because it's like this obscure, from 60, 50 years ago, like, kind of technology that was really interesting and compelling, but it just never really took on because it had some, like, technical issues, use case issues, like how they were trying to do it. And it was the more I kind of looked into it, saw the potential, saw like the massive gaping hole that existed in the market, and then how something like this, and then all of the technology that's come to maturity in the last 5 to 10 years, how you can basically combine all those together. It was one of those that I was like, all right, I got to take a shot at this, because this is one of those things that if I don't, I'm going to regret it for the rest of my life if I don't like really take a shot at this now. And the more people I talk to about it, they're like, yes, let's do this.
Yeah. Speaking of technologies that were tried, or that people attempted to build about 50, 60 years ago, can you tell a story about other forms of technologies that we could be working on now? That the technologies that we have right now could help us build those technologies better and help those projects succeed now.
Are you talking about like just in general?
In general,
I mean,
because you could start like with the moon landing, for example. We went to the moon in 60 something years ago, and we haven't gone since. And there are many other examples of projects and technologies that we just abandoned from decades ago.
Well, and a lot of them, I wouldn't say we necessarily like full on abandon. It was a lot of stuff, like all of the really cool stuff in aerospace was first tried out in like the 50s and 60s. Like, that's when we were going faster than the speed of sound, going 5 and 10 times faster than the speed of sound. I mean, like the time between the X1 and the X15 was not very much time, and you saw like, okay, we just broke the sound barrier to now we're going 10 times faster than the speed of sound. So supersonics, hypersonics, going into space, landing on other planets, all like space stations, all of those things were first really kind of figured out and pioneered in the 50s and 60s, but most of those didn't have really solid economic drivers behind them.
Yeah.
It was all governments pushing for them for like defense or bragging rights or strategic situations, which made sense. But as we kind of moved past those to where they became more ubiquitous on the kind of government side, it's taken a while for like the needing to be able to launch massive amounts of satellites into orbit cheaply.
Mm-hmm.
We weren't doing enough stuff to really need that as a technology until you started to have the internet, telecommunications, and all these other systems getting into place where it made sense of like, oh, we have now a huge need to have large numbers of satellites in orbit. Okay, now let's figure out how to do that a lot cheaper than like the space shuttle or any of these other systems that were tens of millions, if not billions of dollars per launch, which is awesome if you're launching like a super spy satellite or GPS satellites. But if you're trying to do a low cost communication network or geo observations or weather monitoring or all these other things on a commercial scale, you got to get those costs down. So that was kind of the driver behind like having massive amounts of companies working on space launch and stuff like that. You had governments were pushing for like the Concorde to exist.
Yeah.
The economics on it were kind of questionable at the time, which is why it stopped flying. You also had crashes. People didn't want to fly on it anymore. But now it's gotten to the point where our world is so much more interconnected that on an economic standpoint, and as technology has progressed, that now you have companies working on supersonic passenger travel again, like Boom. You have companies working on hypersonic passenger travel like Venus and Hermes, because there's an economic pull for it. Like people would want that. Like you're saying, oh, I could go from New York to London for the cost of a business class ticket in 90 minutes as opposed to 6 or 7 hours. Yes, please. Thank you. Because it changes how the world can work and how we can do like business, relations, interactions, all of those different things. And it's really been now that we've kind of matured on the economic side that there's starting to be a pull for all these technologies to kind of be dusted off and tried out again with all the advancements we have in our modern capabilities, but to serve real economic demands that exist now that didn't really exist in the 50s and 60s.
True. All right. Before we get into the technology, let's talk about how you've assembled like the Avengers for this startup. Can you quickly introduce your core team and what they're all about?
Yeah. So on the actual core team, it's me and my co-founder, Scott, who is so myself, Scott, he is a world-class aerodynamics engineer. Like he was head of flight sciences at a company called Radii up until recently that building an aircraft to fly wind turbine blades out into wind fields to drop them off because they've gotten so big you can't transport them on roads anymore. And so he's one of only 2 or 3 people, I'd say, probably on the planet that's led a team designing an aircraft this size, like what Leviathan is trying to do before. So kind of the perfect person to have involved. His entire background is all in the actual design, computer simulation, computational fluid dynamics, all that stuff. And then also, I was very, very specific on building out a really solid advisory board too. And I kind of treat them in aggregate as a third co-founder involved. So I've got people like a UT aerospace engineering professor. I've got a former NASA CFO. I've got a former head of UPS Ventures and who was at UPS, so has tons of experience on the logistics side. Got a CEO of Saildrone who has tons of experience not only on operations of a kind of large size startup, but he was also at GM and Tesla handling their production process and running things. And a handful of others that all have very kind of specialized skill sets. When you combine them together, it acts as basically a really solid generalist third co-founder to help fill out that. And all of them are very active and involved, some of them putting in way more hours than I would ever ask them to do and way more effort that has just made things. Professor Zwerneman, who's one of our main advisors, one of the key people involved in the B-2 stealth bomber program, and retired to being an aerospace engineering professor at UT, has put in massive amounts of work on this because he's just that excited about it. And he's even told me that he's started dreaming about this because he's so interested in it. And I'm like, okay, if I've got someone like him is dreaming about working on this, then we must be doing something right. But yeah, that was the first 2 or 3 months, was just focused on finding the best people I could find to be involved in this. A lot of it was approaching them, expecting them to say I was dumb and that they were going to tell me I shouldn't do this. And then those conversations very quickly turned into how can they be involved and them wanting to help.
Yeah. It sounds like you've built the best possible team. You have very experienced people who are excited to do the work. That's rare.
I mean, that's for something like this, like that's bare minimum. Like you have to have amazing, ultra high quality people from the very, very start. Just getting started off it. But I think for the stage that we're at and how kind of really early we are, and the fact that we basically bootstrapped everything so far, very little amount of money coming in, to have the people involved that do already have involved, I'm constantly blown away by the caliber of people that I'm just talking to and texting on a regular basis.
Yeah, absolutely. All right, let's talk about the design and technology and everything else. You already talked about how the Leviathan is inspired by a Russian aircraft built in the 1960s, or Soviet era aircraft. Built in the 1960s. So how does Leviathan differ in terms of modern technology? What has happened over the past 60 years that makes Leviathan a much better aircraft or
vehicle?
Machine. Let's call it a machine.
So a bunch of things. So a couple of the issues that Soviet Union had with, especially the one that everyone knows is the Caspian Sea Monster, the Ekranoplan, that design wasn't really able to fly super high off the water. Alexeyev, the lead guy on that program, he had a shipbuilding background. His background was all hydrofoils. And so he kind of approached it from sticking big stubby wings onto a ship to make it be able to fly and be faster, which meant it couldn't be very high off the water, which meant it had to be operating in very calm seas. It couldn't turn very well. There's a whole bunch of issues with it. They also had problems with the big jet engines they were using, sucking in seawater and like having massive maintenance problems. And they had a person actually manually flying it. So flying by hand 15 feet off the water, going over 300 miles an hour, basically requires perfect focus. And our squishy little human meat brains aren't good at doing that for hours on end. And they actually had one crash and be completely destroyed because after 2 or 2.5 hours of flying, the pilot just made a mistake and came down a little too fast. And then they had another one later on in the 70s or 80s, had another almost crash where they kind of bounced off of a wave, and it was pilot error. The other program, so there's another guy named Roberto Bartini that was working on, he was an actual back then it was an aeronautical engineer as opposed to an aerospace engineer, but he approached it from designing an aircraft that could maximize ground effect flying in it. It could fly much higher while being a smaller vehicle and still being ground effect, which makes it a much more optimized vehicle. So that's part of what we're taking into it, is making something that can fly higher off the water so that we can go over waves, we can go over kind of open ocean and all that stuff. But as far as like the actual technology being incorporated into it, so we're going to use hybrid electric propulsion system. So use turboshaft engines, running generators to power an array of ducted fans. This is all stuff that like is fairly new, and thanks to a lot of being worked on in electric aviation and also like electric vehicles in general, has given us access to much lighter weight generators, much lighter weight electric motors, batteries to use as kind of a buffer system, the advancements in turboshaft engines. We're going to use just regular off-the-shelf, probably helicopter engines that there are tens of thousands of them for us to use, and starting off we'll be able to buy them surplus, so that makes things cheaper and easier to do on that side. You have autonomous flight controls, so the actual process of maintaining level flight. There was the really hard part that person, like the pilot, had back then. That's right in the realm of autopilot flight systems that commercial jets have been using for decades now.
Yeah.
It's very similar to that. That's a well understood thing. Being able to automatically take off and land. Also, like, we're going to have to tweak it and adjust it for it being on water and how we're planning to incorporate hydrofoils to act as landing gear. But again, that's a well-traveled path as far as the controls and operations side. Having automatic waypoint following to have it be able to fly itself across the Pacific Ocean, that is an infinitely easier problem than like Waymo or Cruise having cars autonomously drive themselves across downtown Austin or downtown San Francisco.
Yeah.
So that's been more or less kind of figured out for us.
Yeah.
Then you have like obstacle detection, so long-range sensor systems, whether it be radar, or computer vision, infrared, all these other different systems. Those have all been kind of well-worn paths now that didn't exist back in the 60s and 70s. Then you have modern manufacturing, so you're talking about composites and new aluminum alloys, being able to use those to make it much lighter and much stronger, but also being able to make them bigger and in a more efficient way. It's kind of the combination of all of those things. Even launch costs for satellites being cheaper, which doesn't sound like it would have anything to do with us, but it means now we have access to things like Starlink for real-time high-speed data uplink everywhere, even in the middle of the Pacific Ocean. That kind of communication technology didn't exist back in the 50s and 60s. Also means there's now multiple companies working on real-time weather monitoring everywhere, even in the middle of the Pacific, which means we'll be able to see like, oh, storm here, here, and here. All right, so we need to weave along this path to kind of say in the calmest seas possible to make it more efficient.
Yeah.
We'll have real-time weather monitoring to where we can adjust things as needed on the fly, or see, oh, there's not a clear path. We'll just stay in harbor until a clear path opens up and then be able to go out. That was something they didn't have in the 50s and 60s and 70s, because they had to have actually, like, when they were testing the Caspian Sea monster, they actually had to have boats on regular intervals to act as spotters because they couldn't see past the horizon.
Yeah.
So they were relying pretty much solely on their eyes and maybe a little bit of radar, which meant it was kind of dangerous for obstacle detection. For us, all the commercial traffic sticks to very predictable lanes. They have AIS to broadcast their locations, and we'll have much better radar and tracking and obstacle detection systems, which means we'll be able to automatically see stuff much farther off in the distance, and then the computer can instantly take action to start going around whatever it sees. So it's kind of all of those things coming together from lots of different industries being able to make this much more viable than it was 50 years ago.
Yeah, a lot has happened in 50 years.
Yeah.
A lot. So, I mean, I can see how this is going to be a lot different, a lot more efficient. And we'll talk about the ground effect that you mentioned just now. But I want you to give the listeners, especially the audio listeners of the podcast, a description of what the Leviathan looks like.
Cool. So the configuration we're really kind of playing around with most. There's two possible ones. This is the fun thing about being this early is we're still dialing in what it's going to look like. But the one that we've kind of shown the most, imagine two Boeing 777s aircrafts with a giant wing section spanning between them, and then tandem wings on the outside of it. So it almost looks like a flying catamaran. And the reasons behind that is because it gives us a large amount of internal volume, and it gives us a very large central wing section to provide a whole lot of basically interaction with the ground effect. It means that we'll be able to be much higher off the water, which makes it safer for going over waves. But it looks very much like an aircraft.
Yeah.
Whenever I tell this to people, their first thought is usually like blimps or like a hovercraft with a skirt or something like that. Usually what people think of. And then I show them pictures and renders and like, oh, it's just a cool, crazy looking aircraft. I'm like, yes, that's exactly what it is. But it's about like when you add up all of like the volume and the size of it, it's about twice the size of a 747, but it takes up about the same kind of area as one. So it's just more efficient as far as like how much material you can shove inside of it.
Wow. So it's two big planes sharing a wing, basically.
Pretty much.
So
Yeah.
you're going to have engines in that middle shared wing too. Underneath it, if it's like a plane, you have engines underneath those wings, no?
No. So we don't have anything underneath it. So the propulsion units, all of the electric ducted fans are actually going to be built into the leading edge of the outboard wings. This is one of those fun additional. So one of the things that I'm really obsessed about is not just efficiency, but getting ideally multiple uses out of the same bit of technology. So one of the things you can do with a distributed electric propulsion system, which is technically what we're using, is you can incorporate them into the leading edge of the wing and have it so that their outflow, which is not only providing your forward thrust, but you can have that blow over the wing itself, which is now what is called a blown wing system, which adds more lift to the vehicle because you're basically using the high velocity outflow of the ducted fans blowing over the top of the wing, which gives you more lift. So it makes it more efficient. So you're basically getting two benefits out of that energy you're putting into the ducted fans. That central wing section is actually going to be mostly cargo space with probably space for where the generators will be. So we'll probably have all of those turbo shaft generators will be lined up on the trailing edge of that wing section. So they're pulling in air right from the top of it and then blowing out their exhaust on the trailing edge, because we want to try and be pulling in air from areas on the vehicle to where we're least likely to be sucking in salt spray, just to make it that much better on the maintenance side for those turbosaft engines.
Cool. The Russian guy that you were talking about earlier on, Alexiov. You said he built it. Basically, took a boat and put some wings on it.
Yeah.
Right. So, in terms of your design, did you try to incorporate like aspects? Well, obviously, you talk about having it's like a plane, but did you try to incorporate aspects from ships or boats into it also?
Yeah. So the lower part of the hull is going to have to be like, we're trying to make it as little optimized for water travel as possible, and the way we're going to be doing that is by incorporating hydrofoils to act as our landing gear, basically. So we'll use hydrofoils for high-speed taxi. So basically, once we get out of harbor to where we don't have to worry about any kind of speed limits, it'll very quickly be able to get up onto the hydrofoils, probably at less than 15 miles per hour is kind of really what we're targeting, which means we can really streamline the lower hull mostly for aerodynamic operations as opposed to hydrodynamic. So optimizing it to go through air as opposed to water. Then we can use the hydrofoils to basically travel very quickly out to where we're going to do takeoff and landing operations, because we want to do that ideally kind of far away from where there's lots of surface traffic, just to make that safe. Then get out to that area, accelerate up to basically the maximum speed of hydrofoils, which is about 60 knots. And that's one of the things that we're really incorporating into the design, is making sure that, like using blown wing system and some other fun aerodynamic tricks to get our takeoff speed to match up with that maximum speed of the hydrofoils, so that when it actually takes off, it won't like take off like most people normally think of as like an aircraft doing. It'll literally, like if you're watching it, it'll be going along and you'll just suddenly see the hydrofoils retract up out of the water, and it'll keep going along at that same height. So it'll look really kind of crazy when it does that, assuming we can pull everything off how we think it will. But yeah, we very much came from the side of designing essentially an aircraft to maximize ground effect, and then just incorporating the minimum amounts of boat technology to be able to land on the water, take off on the water, and kind of do whatever water-based operations we need.
Okay. That's it's pretty interesting. Now, I started thinking about this ground effect thing a bit more. You've mentioned it several times. How is Leviathan using the ground effect. And what is the ground effect? Actually, let's define that.
Cool. So ground effect is basically the aerodynamic interaction between an aircraft and the ground. It's really like any surface. It could be ground, it could be water, it could be whatever. And people have known about this, pilots especially, since the first aircraft ever flew. And there's two aspects to it. So one is it can decrease your induced drag, which is basically like you've seen the tip vortices coming off of wings.
Mm-hmm.
It squishes those out and moves them further out from the wings, so you get less drag created by that, which is your induced drag. The other thing too is there's it can increase lift by, depending on the size of the wing, you essentially ram up air underneath it and create a higher pressure zone underneath the wing that can increase lift. We're going to be trying to incorporate both of those aspects. It only starts to become, if you're a normal pilot in a normal aircraft, it's something you have to deal with or overcome. For us, it's something we want to take advantage of. But it only works when you are about one wingspan above a surface. So that's where it starts to actually have an effect. Where it starts to really get interesting is when you're less than half of your wingspan above a surface. And where we really want to be is in that like 10% wingspan above a surface range.
See.
And when you start to do that, you see a dramatic increase in your lift to drag ratio, which is kind of the golden number when you're talking about efficiency of aircraft. And for the best commercial aircraft today, like whether you're talking about your A350 or your 787, their lift to drag ratio is usually in like 18 or 19. And over the last like few decades, we've only increased that by a few points. Like it's really hard to add more to lift to drag ratio, which is why it's so important. Ours is looking to be well above 30, depending on where we're going to be operating at. The lower we can get, it gets into the mid 30s. So roughly double the lift to drag ratio, which means double the efficiency.
Yeah.
And that's why you do it. Because when you look at like efficiency of an aircraft flying, you have this like, you start off at this very, very high point.
Mm-hmm.
And then as soon as you get out of ground effect, it drops down because now you're traveling in really, really thick, dense air. And then it comes back up to being more efficient once you get up to full altitude. But that peak of it over there still never gets to the point of where you are when you're in ground effect. The problem is it doesn't really work when you're flying over actual ground because there's hills and trees and buildings and people and dogs and all these things that you don't want to run into that otherwise you would. But when you're out in the middle of the ocean and there is just a whole lot of nothing, that's when it starts to be really useful and interesting because you're in a situation now where you can take advantage of it.
Wow. So a lift to drag ratio for a plane is 18 to 19, or the best, most efficient planes.
For larger size commercial
Larger
jets,
ones?
like when you're talking about like gliders and stuff like that with the super long aspect ratio, those can get up into like 40 and even higher. Really, really efficient, but they're ultra lightweight. They can't carry very much, and they're not intended to do large amounts of transport. They're designed to be ultra efficient gliders. Like you can build very, very efficient normal aircraft. They're just not usually useful for like transporting massive amounts of cargo or people or anything like that. For us, it's more so looking at like the large commercial jets as the comparison, because that's who really is our competition when it comes to transporting large amounts of cargo across oceans.
Yeah, I'm thinking about the effect of surface area and in the field of when you're talking about fluid dynamics. In this case, you were talking about how the middle portion is very important for the ground, for the ground effect. Can you explain that a little bit more?
Yeah. So one of the things that one of the potential issues you run into is waves. Not just the wave height, because you want to be able to take advantage of ground effect high enough to be off the wave, but that undulation can make it less efficient. And the way you kind of get around that is by having a wing that has a really deep chord to it, or a lifting body fuselage that has a really deep chord section to it. And basically, the bigger you make that, the less of an effect a wavy surface has on it. And then also the higher you can be off the water. So the way I usually try and compare that and talk about it is like for a boat, is a 6-foot wave big or small? Depends on the size of boat you're talking about, because if you're in a 3-foot dinghy, it's giant and it's going to flip you over. But if you're in an aircraft carrier, a 6-foot wave is literally nothing. And that's really kind of how you make these viable for going across oceans. You just have to scale them up to a certain minimum size. And that's why we have like that central large airfoil section, is to have that large aerodynamic area to basically help push us up even higher off of the water while still being able to have that dramatic increase in efficiency. Yeah.
Plus, you don't have any plans to be operating in the North Sea anytime soon, all right? So,
no,
that's waves should not be too much of an issue.
Yeah, all the routes that we're looking at that's one of the other like kind of unobvious benefits that makes this really viable now, is that basically the entirety of the global economy and human society has spent the last 40 years optimizing how we move cargo to go into only a handful of very concentrated areas. So when you look at like Port of Los Angeles and Long Beach, 40% of everything coming into the US, or at least on the West Coast, comes through that one tiny little area. So if we can go and tap into that, we can now tap into the rest of that distribution system going from there. And it's the same for a whole lot of other countries. You only need 1 or maybe 2 access points, and you just rely on the rest of the already established distribution system to move things the rest of the way across, whether it's the country, state, or whatever you're talking about.
Yeah. That's very... But so the surface area helps mitigate average wave issues, right? How about the weight of the vehicle itself? And what's the typical cargo to vehicle weight ratio? And is the efficiency of the vehicle affected by, what's inside, if it's empty versus if it's full?
So as far as like its actual efficiency, not really, because most of that comes down to drag. Like you are going to be having to burn more fuel to get it like out of the water and accelerate it up and everything. For us, it's we can carry, right now it's looking like we'll be able to carry about double of what a 747 maximum can carry, while burning less total fuel than a 737. And if you look at it at a per ton basis, it's like half the fuel. On some of the routes, like some of the numbers we're running, it's actually 60% less fuel per ton compared to your standard 737 freighter, which is in the process of becoming the most ubiquitous air freighter there is. 767, I think, still holds that title, but most of them are getting really old and getting phased out. 737s are kind of taking up and becoming the new ones. So that's really kind of, when we're looking at fuel burn, payload capacity, all that stuff, most of what we're comparing ourselves is to the 737. And yeah, it means we can carry 2.5 times the tonnage of that aircraft while burning considerably less fuel per ton.
Wow.
Yeah.
Yeah, okay. So efficiency is not dependent on the weight necessarily. It's affected by lift.
Yeah, it really comes down to the drag on it, your lift to drag ratio. We also have one of the benefits to this that is kind of non-obvious, but we think is going to be huge, both in the performance, but also in like dramatically reducing the cost to design and build it, is that we fly so low, we never have to worry about pressurization. Like the reason that aircraft are tubes is because they're flying so high, you have to pressurize the cabin so that like people don't die. And so that if you have stuff on board that doesn't want to be at a very, very low amount of atmosphere, it doesn't have any issues either, which means you're having to inflate the inside of it basically like a balloon. So now it's having to resist that stress and also those cyclic loadings, because you're constantly inflating it and deflating it, inflating and deflating it. Like that's the reason that the windows are circles and not squares, because they did squares to begin with and then it cracked and exploded. We don't have to worry about that at all. Like we don't have to worry about pressurization or any of these other issues. So we can make the actual cargo hold geometry optimized for the cargo itself, and we have a lot better volume to drag ratio because we're not having to design it around a pressure vessel, which means we can fit a lot more cargo in it. It means we can use, like we're not having to design for those forces and that loading, which means that in theory, it should make it a lot cheaper and easier to build the components that go into it and design it, which then just adds to the efficiency and make it more cost effective.
So you talked earlier on about waves being an issue that you've mitigated based on your design. But what are the other issues involved with flying at low altitude? Like, really harsh weather, wildlife, what?
Yeah. There's a lot of stuff. So in all of our business models and everything we've run, we're just across the board assuming we lose a week per month to weather delays. And we're just going to factor that into all of our basically guaranteed travel times that we provide to customers. Just factor in a buffer time to kind of account for 90 to 95% of our normal expected weather delays. But that is one of the issues you run into. Like, you fly low, you can't fly over the weather. You have to fly either through it, which we're not going to do, or you fly around it, or you just wait for a path to clear it, because that's going to be our strategy. It's either like we're designing it to be able to operate, so actually fly in sea state 5, which is what starts to be considered rough weather. Be able to take off and land in sea state 4. Those are basically straight from the requirements for DARPA's Liberty Lifter program, which we can probably talk about later. But then if we can't fly over it, we fly around it. So use satellite information and other weather data to kind of plot a path of smoothest water, or we just wait and don't leave harbor and just wait for a path to clear and just use up our buffer time that we'll have already baked in. Already thinking a lot about that, because that's one of the things we'll have to do. And like you mentioned wildlife too, like I've had multiple conversations with advisors and my co-founder thinking about how we deal with that. And right now our plan is long-term, by the time we actually launch, we might be able to use full-on autonomous drones. But really the plan right now is to just have someone in a Cessna fly out to where we're going to land and have like a down-looking image package, like cameras and other things, and use like regular computer vision-based detection things to spot whales and dolphins, because when you're flying above, you can actually see them really deep down in the water. And if they're near the coastline, they're not usually that deep. So we'll just hire a pilot in a Cessna. Like when we know a Leviathan's coming in, they'll fly out there, scout out the landing area, make sure there's nothing in the way. And then once the Leviathan lands and then is coming in on hydrofoils, we'll just have the Cessna, or by that point, maybe full autonomous drones, will just be flying overhead, looking down, scouting for like not just also like whales, but also boats, surface ships, stuff like that, basically just acting as a spotter as it comes in the rest of the way, so that we can go around anything that might cause issues. Especially like it would really, really suck to run into a whale going at 40 miles an hour on hydrofoils, because it would be bad for everyone involved, especially the whale. So if we can very simply just have someone in a like normal general aviation aircraft flying out there, or ideally autonomous drones, which thanks to certain conflicts happening in the world right now have seen amazing advancements in the last 2 years, be able to use those to basically act as a spotter to make sure that we don't run into things.
Okay. Have you considered biosensing?
I mean, as much as we can do that so that wouldn't really work when we're actually flying. When we're landed and traveling along in the water, maybe there's a possibility of using sensors mounted into the actual hydrofoils themselves. The problem you run into is traveling at that speed, you end up making a lot of noise and having a lot of cavitation potentially, which makes it hard to pick stuff up. If we can do it, absolutely. Because the more layers of data collection we can add to this, the better we will be at spotting things that we need to worry about. We're mostly just at this point thinking about how do we do it as like cheap, easy, and low tech as possible. And having somebody fly around in a Cessna looking down is a pretty easy, low tech solution that's well understood. And we can just have someone fly around for the hour or so while it's coming in, which is pretty easy to do.
Yeah, I agree with trying to do it as cheaply as possible initially. And you have an advisor from it was from our GM at Tesla.
Yeah. Who's currently the CEO of Saildrone, which we fully plan to take advantage and probably contract with Saildrone to have some of their vehicles just constantly monitoring like regular intervals along the route paths that we're planning to use to provide real-time information about surface conditions that we can use to inform and kind of calibrate satellite information, because we know if the satellite is seeing certain conditions in certain situations, and then we can pin that with a specific situation on the ground, like this wind speed, this wave height, these surface conditions, then we can use that to train models to know, okay, if I'm seeing this is what it most likely is on the water surface. If I'm seeing this other situation, this is what it most likely is. So we can use that as a feedback loop to build out a really good understanding of what our routes look like in real time.
Okay. So many things to talk about there, but just to make a point about doing things as cheaply as possible, at least at the beginning, that seems to be a model of some of these bigger companies, including Tesla. I actually was listening to the CEO of, I can't remember what company, it was a software company, who was just so high on praise for Tesla and about how they try to do things as extremely cheap as possible, and how the CEO is extremely cost conscious and he wants to be like that. So just triggered something.
I mean, that's you have to have that mindset when you're doing something like this. Like what's the minimum amount of stuff we need to do? What's the minimum amount of stuff we need to build? Like, I'm genuinely thinking that when it comes time to build the prototype full-size version of this, we're going to do it in a big tent in the port of Los Angeles, how SpaceX was originally trying to do BFR back in 2018.
Yeah.
Like, we don't even want to build a permanent
SpaceX
structure.
Too, yeah.
Yeah. We don't even want to build a permanent structure to assemble the first one. We're just build a temporary structure, assemble it underneath it. And even if we have to take down the whole tent to get the first one out, cool. That's fine. Because that's going to be cheaper than trying to build out a whole huge factory to start off with, when all we really need is to just have the first one flying and generating revenue.
That's also the advantage of building something unique and different, is that you don't actually need to make the perfect version.
No, and that's also the benefit of our model of building and operating them, is we don't have to figure out full-scale production off the bat. We don't have to have it be the perfect version. Like, we can use surplus equipment. We can use all off-the-shelf stuff as much as possible. We just need to get the first one flying and generating revenue and validate everything. And also, having money coming in is good. Then we can figure out, like, okay, we built one. Now how do we build the next one even faster? And the next one after that even faster. And then start working on, okay, how do we build like 20 per year or 40 per year? And that's when we can start figuring out the production side, which, if you're trying to design something to build it and sell it, you have to have all of that stuff pretty well figured out from like day one, when you're immediately starting to kick off, because you got to be producing them at scale so that you can be selling enough of them to be generating enough revenue to make it worthwhile. We are like going the different route of, we just need to get one built. Doesn't have to be perfect. Doesn't have to be figured out on how to mass produce them. We just need the first one flying and generating revenue, and then we can worry about all the rest of that.
What's the go-to-market strategy here?
As far as customers that we're going to be focusing on, freight forwarders, first and foremost.
Freight forwarders?
Yeah.
So Leviathan will own the vehicles, though?
Yes.
Okay.
Yeah. Unless we might do some sort of leasing type situation, kind of how airlines don't directly buy their aircraft. They usually work with companies that buy the aircraft for them and lease it back to them. Or we might do some sort of loan situation. There's some interesting things we can do on the debt-based financing side down the road. But essentially, yes, we will build, own, and operate the vehicles to provide this transport service, but in a very targeted and focused way of just port-to-port transport. So, like, if we were to work with someone like Flexport, they would contract with us to act as a link in the supply chain that they are planning and building out for their customers, to where we get ready to go air freight pallets dropped off at our facility on one side of an ocean. We move it to the other side. They get picked up. We hand it back off, and we don't deal with any of the other aspects. We don't plan it. We don't do the logistics. We don't do the paperwork. We just move this chunk of mass from one side of the ocean to the other side of the ocean, and we don't care about any of the rest of the process.
You think it'd be easier to scale if you just act like Boeing, for example, and just supply the planes to existing shipping companies, for example?
No. One, I don't think the economics works out better. So I just learned about this during Deep Tech Week out in San Francisco, that apparently, I think it's either United or American Airlines was actually started by Boeing. And so they were building and building planes and running their own airline. And it was so efficient, laws were passed to break it up because they were crushing everybody else. And so that's why you don't have, part of the reason you don't have like Boeing building and operating their own aircraft. Granted, this was back in the 30s, it was or 40s, somewhere in there. Bit of a different situation, but SpaceX has shown that like building and operating to provide the service can be an incredibly lucrative way to do something if you're able to do it efficiently and kind of very strategic and smart. We also aren't entirely sure that there would be anyone to sell to right off the bat, because air freight operators don't usually understand things that float, and ocean freight operators don't usually understand things that fly. And this is going to be both of those. So at minimum, we think we would have to build and operate the first few of them just to demonstrate how the whole process would work and how everything would flow. But when we look at like the revenue potential to be made from these, especially if we're the ones building them and able to make them kind of lower cost because we're not selling them to everyone, it makes the economics look really compelling for building and operating, as opposed to trying to sell 50 of these a year or whatever we need to do to make it worthwhile.
What happens if the Leviathan needs to stop for whatever reason?
Like if there's an issue out in the middle of the ocean?
I
mean, we land. That's the nice thing about being because we take off and land on the water and we're flying over the water. So unless we're just like suddenly got caught in a magical storm that appeared out of nowhere, everywhere we're flying over is our runway to where we can just land. We're going to have some testing done on how exactly we would do that. Like if we needed to do it very, very fast, basically, okay, if you're traveling at 300 miles an hour, how do you safely slam on the brakes and then get down on the water? There's a few things we can theoretically do on that. But basically, if we have an issue, we just land, and we can either have it just sit on the water and wait for someone to be able to come and get it if it had like kind of a more or less a catastrophic failure to where it wasn't able to get going again. Or it could be a situation where whatever the issue is gets resolved and then it just takes off again and continues on its way.
Cool. Okay. The ocean is your playground, basically.
Yes.
It
is both our playground and our nightmare at the same time.
Speaking of Boeing, right? Everyone knows what's happening with Boeing right now. Pleading guilty to defrauding the FAA on the quality of their planes. Bolts coming loose, windows getting blown out, 737 Maxes, crashing several years ago. These are American-made planes, right?
Yeah.
And Leviathan will be American-made?
Yep.
Yeah, American-made is not, it used to be, a very highly regarded brand, and hopefully it still is, and despite what's happening with Boeing. So why do you think, what's your opinion about why, these planes are actually having issues, and how would you avoid similar issues?
Well, I mean, I think a lot of what's happening with Boeing can be tied to the merger with McDonnell Douglas. And McDonnell Douglas already had established a culture in itself of focusing on stock price and margins and cutting costs at all costs. And that culture basically ate Boeing from the inside like a cancer when they merged. You saw them move the headquarters away from the factory to Chicago, to where you had the people who were running the company no longer really interacted with the people who were building the aircraft. You saw like massive refocusing, less on like quality and making an amazing product and making amazing aircraft, and focusing on the stock price and doing stock buybacks and trying to cut costs and increase margins and all those other things. And I think they optimized for the wrong things that then set up a culture that was incentivized to not make safe aircraft. It was meant to make cheap aircraft so that they could make more money and have a better stock price, which is a bad incentive structure for when you're talking about something transporting hundreds of people at a time. And we saw what happens with that when you had them start falling out of the sky, or door plugs blowing off of them. No, our focus is always going to be on how do we make these the best that they can be for what they need to do.
Yeah.
We do have some advantages of that. We should be certified with the Coast Guard, which means, at least if things play out, we won't be going through FAA certification, which will streamline things on our side, but we'll still be focused on how do we make these as reliable as an aircraft? How do we make sure that they're going to be able to operate safe? Fortunately, since our focus is wanting to have these be uncrewed and be autonomous and only focusing on cargo, that means that if there is an issue, we at least don't have people on board on our side. But then it's also, how do you make sure that we don't like run into other boats and other things out on the water? And that has to be like the core focus, is how do you make these reliable, safe, capable? And I think a lot of that is that we want to be building and operating them all in the same area, like having the people who are doing all the design work, the people who are running the company, be working in the same building and with the people who are building them on a day-to-day basis. So you have that feedback loop of, if there are any issues, spot them, call them out, make sure that it's known so that it can be addressed before you start having things crash into other things.
Cool. Speaking of the FAA, is it better for investors to hear that you don't need approval from one of the 3-letter agencies?
Yes. Which, and I mean, it makes sense. So the way that we're going to be operating these and the way that they're going to be flying, the top of our tail, even when we're flying 20 feet off the water, will be at the same height. They're probably even less than like the highest points on the largest cargo container vessels or cruise ships or everything. So even though we're going at 300 miles an hour, we're still occupying the exact same space that a ship does. We're operating exactly like a ship in every way, except for the fact that we're going 300 miles an hour as opposed to 13 or 30 miles an hour. So it makes sense to have that set up that way. In fact, International Maritime Organization, which is the international body that sets up all the agreements and regulations for how maritime traffic works, the IMO, they've had on the books guidelines for ground effect vehicles for 20 years now. It's just that no one has been seriously working on it until recently, that process now needs to get kind of run and figured out. There's another company working on shorter range electric kind of people ferry versions of ground effect vehicles called Regent. And we've actually been talking with them to make sure that we're all on the same page of language that we're using, how we're going to be planning to go after certification, registration, all that stuff, to ensure that we do have this work out to where it is a ship, that it get registered with the Coast Guard, gets certified with the Coast Guard, and maybe the FAA is involved in more in providing them kind of technical assistance and feedback on how to ensure that things operate safely.
Cool. Okay. So
yeah, basically, us not, if it works out how it's supposed to and we don't have to go through the FAA, that probably saves us about $1 billion.
Wow.
Yeah.
Okay. $1 billion. Wow. Okay. Because the reason I asked that question is, when you're making medical devices or you're building technology that needs to be approved by some government agencies, investors are like, well, get that approval first, then we'll talk. And that getting that approval, you just described $1 billion. Because of all the testing and all the approvals and everything you need. So, okay, let's talk about automation, right? So that's one of the things that is available to us now that wasn't as advanced 60 years ago. You're talking about the pilot having to actually fly the Ekranoplan over the water and having to concentrate, do it effectively and perfectly, basically. All right. So how will Leviathan operate autonomously? If you can describe it.
So the way we think about it is kind of two levels. The base level is going to be the actual system that is doing the raw piloting. So it'll handle takeoff, it'll handle flying at the right altitude, flying levels, flying straight, stable at the right altitude off the water, and then handle landing. You could kind of think that about that like the reptile brain part of the brain that like keeps you alive and keeps you operating. And then the level above that is going to be the actual system that handles the navigation and the communication and basically tells the base system, hey, turn left a little bit, turn right a little bit. And it's what's following kind of waypoints to go along that autonomous flight path to get to its destination. Now, throughout that entire process, we're going to have somebody is going to be monitoring it. So we will always have a person on the loop, but maybe not necessarily in the loop. But once it lands, and we're actually like coming into or going out of harbor, we will have somebody directly controlling it. So basically remote piloting it as we kind of travel through those higher traffic areas to where you're now needing to probably take into account currents and understandings of the like sea floor and just all of that knowledge that local maritime pilots have for bringing ships into and out of harbors. We want to take advantage of that. Like we don't want to have to try and automate all of that because that actually is kind of a harder aspect to it. So starting off, that might involve having an actual maritime captain be traveling with it along the routes just to simplify that. Again, make it as easy as possible to get it going. But long term, we want to have that be more so somebody sitting in an office like this to where they just like either put on a virtual headset or they're surrounded by screens. And they log into a Leviathan as it lands and is starting to make its way in, and they directly pilot it in. And then once it gets to the dock and gets docked up, this next one right next to it, it's ready to leave. They log into that one, pilot it out, get it to the takeoff area, and then it gets handed over to the automatic system to take off and start traveling across the ocean. It means they would be way more productive. It's also way safer for the pilots as well, because now they actually have to travel on a little pilot boat out to a ship, climb up stairs or a rope ladder to pilot the ship in. They actually lose quite a few per year just from falling off the ladder or having issues on the way out there, to where now they just sitting in a comfortable area, they log in, remote pilot it in, and handle it that way.
Okay, so that's very interesting to see the transition from what is going to be now to almost completely autonomous in the future. But you still want to add that human element to it.
Yeah, we still want to make sure somebody's there to make sure things are operating how they're supposed to. But it means that like we have the harbor pilot logging in and directly controlling one at a time, but able to do many transitions in and out per day. And then we can have another like maritime captain pilot would be monitoring half dozen, maybe a dozen at a time, just all on screens. Like, is everything still green? Are all the dots moving where they're supposed to? And then only if there is some sort of issue detected can they take control of that one and either tell it how to maneuver how they want to, tell it to land, do whatever.
Yeah. Okay. And I'm very curious, and this is not my space, but my field, but I'm thinking that when it comes to cargo transport, a lot of what we do is still with old technology, right?
Yeah.
Like there probably haven't been a lot of advancements in the past, 50 years maybe. And so this technology you're developing is perfect. But in the meantime, are there any other autonomous ocean vehicles right now available?
Yeah, so there's starting to be. There's a decent number of companies working on smaller autonomous ships for like surveillance and military use type stuff. But there's even a couple of companies working on electrified and autonomous larger size ships for cargo transport or for research and observation and stuff like that.
Yeah.
That's one of the nice things, is that we don't have to fully forge that path ourselves. There's some other companies that are working in the same space that are well funded, but aren't necessarily direct competition in how we're going to operate, that are basically showing how we get that done. Like, oh, here's how you have these be able to operate autonomously or with a remote pilot in a harbor. Here's kind of the standard operating procedures for that. Or here's the well-established certification and registration pathway for that.
Yeah.
And we just do what they do. It's the benefit of not necessarily being the first mover, but being the second or third mover is you let the other person find all the traps running the path, and then you just step over the things that they found out were the wrong way to do it.
It reminds me of I'm an avid track and field fan, so I'm watching these long distance races, and the winner is always a guy lurking in the back, like for almost the entire race, and he's just waiting, and then like 1 or 2 laps to go, he just makes his move and then he wins. And it's like, and then you hear these commentators talking about how he didn't have to fight against the wind, he just stayed behind.
And it's for us. Like, yes, on the long distance running, that's one way to view. I view it as more so like forging a new path through like a jungle or something like that, to where the first person is the one having to actually hack their way through it or find like the easier routes or the simpler area, and then we just follow what they do. Especially if they're for the specific aspects of like for autonomous ships. We're going to be a ship. We're going to be autonomous. Like the things that they figure out is the right way to do it, we just do that. Or for the certification with the Coast Guard and versus the FAA and how that's going to be done, we'll just follow that and do that. We're trying to limit the amount of completely new and novel things that we have to figure out and do ourselves, because we already have a decent number that we're trying to do.
Just to circle back on the on what you said earlier on about it's just like an airplane. Do you have any plans or any dreams of making this maybe all electric in the future?
Potentially. So our actual propulsion system is electric. So we're using a whole array of electric ducted fans. So we actually are an electric vehicle. It's just the energy storage systems that exist right now, namely batteries, are unable to store enough power to do the range that we want to do, which is why we're using a hybrid electric system of using either regular old jet fuel, maybe marine diesel, sustainable aviation fuel, if it actually fully becomes a thing, and then running that through a turboshaft generator to produce the electricity that we need. But at the end of the day, we're kind of agnostic to where the electricity comes from. If we can use liquefied natural gas, which would be even more efficient than jet fuel, awesome. If we can use liquid hydrogen, which would be even more efficient than liquefied natural gas, okay, cool. If batteries become power dense enough to where we can store enough energy to cross oceans while using those, awesome. Yes to all of those. That's the benefit of the actual propulsion units being electric we can use new technologies as they come available to provide that electricity. We're just right now trying to use what is easiest to start off with. And off-the-shelf turboshaft engines running electric generators, pretty easy starting point. And regular old jet fuel, pretty easy starting point.
Sustainable aviation fuels, is that biofuels?
It depends on how it's being made. Some of them I'm kind of unsure about. Some of them almost seem like it's kind of a trick of an accounting thing. That said, there are some so there's one company, I think I can talk about what they're doing. I think they've started talking about it publicly, but that they want to use small nuclear reactors to generate synthetic fuels by using the heat from it to gasify organic material. And so they basically would use farm waste, superheat it using the heat from a nuclear reactor to produce synthetic fuels that would be actually carbon negative, because you would have had more carbon would have gotten absorbed out of the atmosphere to produce the total mass of what you're using versus what's burned from the synthetic fuels produced. So we like that would be like their whole business plan is to start off selling jet fuel, but using nuclear reactors to produce green jet fuel. And so if that gets to a point of where we can start buying it from them once we get up and running, that dude's really cool. I got to meet the CEO of that company, and they could end up being our fuel provider. There's some other biofuel based ones to where they're doing essentially kind of like how ethanol is produced, but using it to make jet fuel, that one's kind of questionable. There's a bunch of different ones being worked on. If they actually do produce a total life cycle CO2 reduction versus regular jet fuel, and if it's at a price point that makes sense, then that's absolutely what we'll be using once we get up and running.
Okay. That sounds like a very interesting conversation to have for me, talking about people working on energy solutions and things like that.
That one I really like because it basically flips the whole concept of it from thinking of the liquid fuel as your energy source to thinking about it essentially as a liquid battery. Because what you're ultimately doing, especially for that nuclear reactor one, is you're basically taking the high amounts of energy stored in nuclear fuel and instead converting it and storing it into an easily transportable, safe, liquid hydrocarbon-based fuel that, yes, you then burn, but you've already pulled in that CO2 from the atmosphere from plant material. And even though you're releasing a percentage of that back into it, your net process is still carbon negative, but all of the actual energy from that fuel came from the energy stored in the nuclear fuel.
Yeah.
So it basically turns your liquid hydrocarbon based fuel into a battery that was charged by nuclear energy.
Nuclear reactor. Okay.
Yeah.
I see. Wow. Yeah, that's my first reaction to it. Okay. Wow. Okay. Let's talk about something relating to you having to operate the Leviathan pretty much all day, every day. What would maintenance look like?
So very good question. That's one of the things that we think a whole lot about right now. So one of our other advisors, former Marine, and spent a lot of his years doing maintenance on aircraft in the military. Also has a whole bunch of experience outside in private industry on logistics and stuff. But that's what we've been thinking a whole lot about, is how to really cut down on the maintenance on this, because we're going to be in a corrosive environment, which, yay, that makes things so much fun. Salt water is mean. So everything is going to be either aluminum, carbon fiber, or maybe stainless steel and titanium to cut down on corrosion as much as possible. Seal everything as much as possible. The maintenance side of it is mostly going to come down to the actual propulsion units and power generation systems. And we're actually planning to make those as modular as possible. So we basically have two options we can go with on the power generation side, because that's most of what the maintenance you deal with for an aircraft, besides like checking your flight control surfaces and all of your moving things, is the big, huge turbofan engines hanging on them, or your turboshaft engines. Like your actual propulsion unit is where a lot of your maintenance comes from. One of the ideas that we're planning to incorporate is, so there's a whole bunch of different engines that we have to choose from right now. We can either go with a smaller number of very large ones, or we can go with kind of a larger number of smaller ones. I'm leaning more towards somewhere in the middle to the larger number of small ones, mostly because it means we can, in theory, build them into modular power generating units. So the turboshaft engine, the electric generator, any pumps, coolant, any of those things, all built into basically a big box that plugs into the Leviathan. And you have the air coming into it, exhaust going out of it, fuel going into it, sensors, and then the power coming out of the generator. That's all you would have. You could reduce it down to just a handful of kind of quick connect systems, and then the process of actually locking it into place connects it to where the air comes in and the exhaust goes out. So that once you get to the point of where you need to do regular maintenance on those turboshaft engines, which the way we're going to be running them as a generator means that that interval should be longer, because we're running them at a constant rate. We're not throttling them up and down and using them to provide thrust. They're just running at their most efficient happy point all the time, generating electricity. But once it gets to the point of us needing to do that, the theory is that we can just unplug that module that's up for maintenance time and have a fresh one ready to go that gets immediately swapped in. So I want to try and get it to the point where we can do that swap. And if we could get it to where we could do it in the same amount of time it takes us to do loading and unloading of the cargo, that would be awesome. Might not be able to get it done that fast, but being able to do that hot swap of the power generating units means that we don't have to take the entire vehicle out of service to do maintenance. We're also planning to do, since we're going to have full-time data uplink to this, one of the things that we want to do, and since we don't have any people on board, we can make the inside of it very stripped out and very bare and have all of the systems very well exposed to be able to see everything and visualize everything, from the flight control systems to the power management system, everything. Like have everything on display to where it would look more like the inside of a World War II bomber than it would a modern aircraft. But that means that while it's operating, if we design it right, we can have robots continuously roaming around the inside of it, whether being controlled by someone remotely on shore, or if they become capable enough autonomously, and basically doing continuous inspections of everything inside the vehicle while it's flying the routes. So not having to take the vehicle out of service to do regular inspections. We just have these like either little spiders or robot snakes crawling around the inside of it constantly, checking and making sure everything looks how it should and should be operating how it should. Even down to the actual propulsion units. We're planning to build those into hot swappable modules so that if there's an issue with like one of the ducted fans, undo some bolts, take out that whole unit, have a fresh one ready to go, mount it into place. Everything, all the hookups and everything automatically get locked into place, and then get it back in service as fast as possible.
Yeah, it just reminds me of the fact that there are a bunch of people trying to work on autonomous aircraft inspections. Reminds me of Colby, who we had on the podcast.
Oh, I mean, like that. I fully plan to take advantage of what they're doing to have them do outside inspections every time we're doing cargo and loading and unloading. I'm very much rooting for them to be as successful as us, so that we can take advantage of what they're building and use that. And then while it's flying, we can basically be doing the same, but from the inside out while it's operating, because then you don't have to take it out of service to do inspections.
Yeah, they'll definitely be fine. I mean, UltraView AI going to Techstars recently, I think.
Yeah. The fun thing too is because it's fully sealed, like we're not pressurized, but we're fully sealed. So even though we'll be flying at like 300 miles an hour, we could theoretically still use little quadcopter drones to be flying around inside of it, because from their point of view, it's going to be a solid, stable environment, because we're not going to be doing any maneuvering, not going to be bouncing around. So they could be like, as opposed to even necessarily having to have something crawling around, you could have little quadcopter drones flying around inside of it, doing visual inspections of things, and then go back to their charge point and then do more inspections. There's a lot of fun possibilities on how we can do that, but it means that we should be able to visualize 80 or 90% of the structure, pretty much everything except for the outer skin and the flight control, like the actual like ailerons and flaps and all that stuff. We probably won't be able to access, but everything else we'll be able to do inspections from the inside, and even probably have robots crawling around that have little ultrasonic sensors that can continuously be checking to make sure that all the carbon fiber and the structure and everything is still sound, and that we don't have like cracks propagating or anything like that.
Seems like you're very prepared. All right.
Working on it. We'll see.
Okay. So let's talk about e-commerce. Now, you laid it down very, very well at the beginning, where you said there's air transport and there's sea transport. And air is very fast, very expensive. Sea is very slow and cheap. Well, cheap is relative, but cheaper than air transport, right? Do you think Leviathan will become the primary option for all overseas transport in the future, or are you always going to just have a niche market?
So to put a little bit of context on that, right now, when you look at everything traveling across oceans, ocean freight handles 99% of all tonnage traveling across ocean. Air freight only handles 1%. That said, that 1% of tonnage accounts for approximately 35% of the value of all goods traveling across oceans. Yeah. So very value dense.
Yeah.
That's why we want to focus on that mostly, is offering them a lower cost option for that high value dense cargo, while also still being able to go after the top 5 to 10% of things going across oceans, which is an insane amount of tonnage. Like if we could long term, no, I would be surprised if we end up becoming the dominant form of like based on a tonnage aspect of the transport. That said, I do think we could become the dominant as far as revenue generation and value of goods transported.
Yeah.
Because we can go after the majority, probably the bottom 50 to 70% of air freight, as well as the top highest value stuff that's still stuck on ocean freight that isn't quite valuable enough to go on air freight.
Yeah.
Because basically the way those numbers work out is that 99% of the tonnage that's going on traveling across oceans, like air freight itself, like the actual cost per pound to move something, costs more than the value of that good per pound. Which is why, like, if it's costing just as much as it's worth to transport it, like to ship it, those numbers break down pretty fast as far as being economical. But when you look at the things that are transported on air freight, those things are hundreds of dollars in value per pound. And if it's costing you like $5 or $10 per pound to transport something, then that makes sense if what you're transporting is like $50, $100, multi-$100 per pound in value.
Yeah.
But if what you're transporting is like $5, $10, $20 per pound, and you're trying to have your shipping cost as much per pound, it breaks things down. But if we can cut that air freight cost in half, or maybe even more, once we really streamline our operations, it opens up a whole lot more goods and things that are being shipped on ocean freight to now, okay, maybe those numbers make sense, especially if you're able to open up the possibility to do rapid restocking so that companies don't run out of supply and have to stop sales, or being able to do regular shipments of a lower amount of goods to then cut down on the amount of warehouse space that you're having to store things so that you don't have stock out. Those value propositions are a bit more complex and nuanced, so we'll see how those play out, but we think it opens up the possibility for quite a bit more cargo to use this option versus having to be stuck on a container ship for weeks or maybe months on end.
All right, so you were saying that 35% of the value of goods is transported via air freight. Overall, what's the value of goods transported every year?
Across oceans?
Across continents, just in terms of cargo transport.
Yeah, it's well into the trillions. I think off the top of my head, it's something like 6 to 8 trillion total amount of the goods, value of goods traveling, especially across oceans. So yeah, it's when you look at international shipping as a whole, it's one of the biggest industries or entities that there is.
Yeah. So if you capture the bottom half, or begin to touch the bottom half of air freight customers or goods categories, then the sky is the limit, basically.
Yeah. The numbers get very big very fast, especially like what each Leviathan is, at least based on all of our numbers and everything we've run so far. Like on the first route we're planning to run, going from Southern California to Hawaii, mostly doing that one because it's a U.S. route, so we're not having to deal with customs or setting up an endpoint in another country or do anything like that. It's looking to be total revenue $200 to $240 million a year, with theoretically $185 million of that after operating costs. So our margins are looking to be north of 50%, which for shipping is insane. We're definitely not assuming that that's what it will end up at when we like take everything into account, but we've really tried to be as challenging on ourselves as possible. So like from assuming, okay, we just lose a week per month to weather delays. So that's a week of us not generating revenue. We're using all of our operating cost numbers and per block hour numbers are straight from FAA publications on costs to operate major jet aircraft. So whether from airlines or cargo aircraft or like 747, 3-engine wide body, 2-engine wide body, looking at all those numbers and basically choosing the worst parts of all those things. And it takes into account everything from like maintenance to ground personnel, landing and takeoff fees, even a bunch of stuff that theoretically we won't have to deal with because we're not operating out of airports. We're just landing out in the ocean. We still threw all of that in there and then added on even a little bit on top of it to just try and kind of beat ourselves up as much as possible, because if we could still make the numbers look insanely compelling with trying to make it as hard on ourselves as possible, and it still comes out looking amazing, then even if we're off by a factor of 2 on our operating costs, yeah, we still look amazing on the market. Like still doing 3 to 4x the margins of most cargo aircraft.
Okay. I mean the size of ocean cargo transport or air transport is massive. It's astronomical. You don't even want to start imagining it.
Yeah, if we're able to do what at least the numbers say we should be able to do, and everything we've been working on for the last 10 months says we should be able to do, we are never going to have to worry about supply side.
Yeah.
Like it's literally just going to be how fast can we make Leviathans, because there will always be cargo to fill them as we add on more routes.
Speaking of cost, I know you talked about starting with off the shelf parts, reusing some parts that have been used from some other vehicles or something like that. But overall, how expensive will it be to make one of these vehicles? And would the cost go down at scale?
Theoretically, the cost will go down at scale. We're assuming that once we're actually building them kind of in a row, yeah, it's still going to be north of $200 million for each one, maybe 250. That's just like,
it's not too bad.
Like, yeah, not too bad. Still, yeah, it's a pretty solid price tag
for 2 aircraft.
Yeah, essentially for something that's essentially twice the tonnage of a 747, it's not that bad. But at the same time, yeah, it's still going to be a decent chunk of money. And that ultimately just comes down like the cost of the amount of people that we're going to have working on it, and then the cost of just raw material. Like just even if we're doing a lot of our own kind of processing of certain aspects of carbon fiber and not using advanced like autoclave systems, taking advantage of the advancements in like either vacuum resonant fusion or out of autoclave prepregs and all these other things that dramatically reduce the cost, it's still just a big vehicle. And even if we're using like surplus or off the shelf generators and motors and all these other things, it's still just a lot of mass. But yeah, compared to something like Airbus A380, it's going to be a lot cheaper than one of those.
Yeah.
Just because it's a simpler design, simpler vehicle, simpler to build, other than the fact that it's just big. Okay.
You think you're going to have a lot of Leviathans in the future commuting across the ocean?
Oh, I want to get to the point where we have thousands of these things crossing the ocean. I mean, yeah. That at that point, it really kind of becomes a scale of how fast we can make these and building more facilities to build more of them, and then just ramping up production. Minimum hundreds of these crossing the oceans, ideally thousands of them. I mean, like currently today, there's 25 or 30,000 commercial jet aircraft crossing the world's skies. Most of them are carrying commercial cargo in the bottom of them in extra space.
Yeah.
So compared to what's already been built and what's flying today, for us to have 1,000 or 2,000 or 3,000 of these is still just a fraction of what's already been built and operating. So it sounds crazy, huge, and ambitious, but when you look at what's already been built and what's already out there and operating today, it's, I wouldn't say reasonable, but it's doable.
You know, once you have like hundreds of thousands of this on the ocean, you know, on the surface of the ocean, you're gonna have people start asking you to transport people too. So instead of having Delta, American, United, or whatever fly from Los Angeles to Hawaii, now they're like, well, it's the same speed. It's cheaper to do.
So not quite the same speed. So we're still going to be at aircraft speeds, but think more turboprop as opposed to like jet aircraft.
Okay.
So we're going to be cruising at about 300 miles an hour as opposed to almost 600 miles an hour.
Okay.
So a little more than half the speed of a jet aircraft. I don't know. People is one of those, like I've had a lot of people ask about that. The problem you run into is that if you're going at half the speed of a jet aircraft, it takes twice the time to do it. Now,
Right.
cargo doesn't really care about that because cargo cares about the total transport time.
Yeah.
And when you look at, say, if you're trying to do something air freight from Shenzhen to LA,
Mhm.
that when you go and look at that, most quotes are going to put it at like 3 to 7 days to do that whole process. Even though the flight itself on a commercial jet only takes 12 hours.
Okay.
Because there's all the other steps involved in the process of getting it picked up, getting it repackaged for air freight, getting it taken to the airport, getting it dropped off there, waiting for the flight showing up, getting loaded, actually flying. And then you do all those other things in reverse to the other side. So even if we take twice as long for the flight, okay, now it's 3.5 to 7.5 days. It doesn't matter. The cargo doesn't care. But if you're talking about people, a 12-hour flight versus a 24-hour flight is a big difference.
That's true.
That means being stuck inside of a tube for 24 hours as opposed to 12, which I've done. I've done to the direct flight from Dallas to Sydney on an A380, which is like the biggest, roomiest aircraft there is. 15 hours inside of an aircraft sucked a lot. I couldn't imagine if it was 24 hours or like maybe even a bit more, depending on what exactly our speed ends up being. Maybe that'll end up happening. I don't know. I don't know if people would want to do that. I'm not sure if that's something we would even want to do. If somebody wants to start I don't know, like a luxury cruise version of these to where it's like all first class and you're traveling in style or something like that, we can maybe sell them ones. We probably won't ever handle that or operate that. We want to focus just entirely on the cargo. And then we can let like Boom and Venus and Hermeus and all these other companies that are working on making air travel over oceans faster and better for the actual passengers. Let them focus on the
so these three companies are making like ground effect vehicles.
No. They're doing like supersonics and hypersonics, but their prime focus is people or weapons for some of them that are focused on DoD applications. But I mean, even commercial jets, I think because that I don't know. If people would like, even if it ended up being cheaper, if they'd want to be stuck inside of one of these things for twice the time.
Okay, so in the future, you have 1,000 Leviathans, thousands of Leviathans on the water over different continents. That changes the economic outlook of this continents, these countries, and economies start changing. Whenever a company becomes really big and takes over and does something different, it changes the entire economical landscape. Look at Amazon, for example, putting companies out of business, changing the way we shop, changing the way we receive things. What do you think that would be like for Leviathan?
I honestly don't know. And that's what I'm kind of most excited about.
Try to predict the future.
Yeah. I mean, like we spent a lot of time thinking about what this would look like, of like if you made air freight cheaper, you made ocean freight faster, and how that could be used and taken advantage of and the benefits that could come with it. But what it ultimately comes down. So one of my favorite books, especially on logistics or anything like this, is called The Box. And it's about the history of the shipping container, which sounds like it would be a really, really boring, uninteresting book, but it's actually like really cool. And one of the really cool things to see is a lot of the people involved in kind of pushing the concept of containerized cargo. Yeah, they had some ideas of how it could make things more efficient or make things easier on their operations. But I don't think any of them saw where things are going to be, like where things are at today, where you have entire industries reshifting and setting up these like to where you do this part of the production here, and then you ship it to the other side of the planet to assemble it, and then you ship it back to the other side of the planet to sell it, to do all these things, because it made it so efficient to where you could have these crazy long and complex supply chains that were possible because of that system. And it was because all of these like really smart and in some cases like very ruthless and devious people were given this new tool to take advantage of from an economic standpoint. I'm really kind of curious to see what happens when we offer now the tool of Leviathans to the global economy and see how it gets used for that. I think it will be a massive benefit of being able to make things more connected, make things be able to operate smoother and more efficiently, ideally dramatically cut down on CO2 emissions that are being like emitted from moving stuff quickly across oceans. But then, okay, how do things start flowing if you're not having to like spend a whole lot to do air freight or order a whole lot at one time to do ocean freight? If you can be much leaner, much more agile, be able to update the parts and the supplies that you're doing quicker, what does that do for supply chains? I don't know, but I'm excited to see what happens.
Okay. I mean, you hit the nail on the head. It's really hard to tell, but I mean, look at the electric vehicle space. Look at so many industries. Once one entity becomes really big and starts to take huge market share, everything just shifts.
We have launched, and by say we, I mean humanity. In the last 2 years, I saw this literally earlier today. In the last 2 years, we have launched more satellites into orbit than in the entire time period before those 2 years. And like from when we launched, Sputnik got launched to 2022, we have launched more satellites than in that entire time period in just the last 2 years. Because SpaceX, Rocket Lab, Astra, and all these other ones, as well as like the actual government entities, have made it so much easier and cost effective and able to do that to where you have all of these huge industries are starting to kick off to take advantage of that new tool being available.
Yeah.
That's kind of how we view these. It's like, okay, let's see what happens.
Just to clarify real quick, you will never need approval from the FAA for Leviathan to be adopted globally?
If things work out how they're supposed to. That's still getting figured out right now.
Yeah.
Like, I can't be 100% sure on it because that's actually like, it was just came out recently that as part of the FAA's rechartering or recertification thing, that basically it was stipulated in that, like explicitly talking about ground effect vehicles.
Yeah.
And when you read the language, it's talking about type A IMO ground effect vehicles, that basically the FAA and the Coast Guard have 2 years to kind of figure out who's taking point on it. And at least based on everything I've been hearing from people who are talking to them firsthand is, Coast Guard's going to be taking point on it. FAA is going to be basically helping them with understanding what things they need to be taking into account with how these operate.
Cool. Speaking of transporting people, right? There's this company called Navia that's created an electric hydrofoiling vehicle that transports people over water, but the vehicles are very small. What are your thoughts on that?
Oh, I love it. I actually got to see one of them sitting outside the opening party at Deep Tech Week in San Francisco a couple weeks ago. And I've been following it since the very beginning. I think all of these new hydrofoil boats, whether you're talking about Navair or I'm blanking on the other one that's out of Europe. I'll probably Tourette's it here in a minute. Or even Velo. I got to meet those guys that are doing hydrofoil-based personal watercraft. I love hydrofoils. I think they're super cool, and we're going to take advantage of them. And I think it makes a lot of sense for, especially when you're talking about the electric ones, Candela. That's the name of the one out of...
Candela?
Yeah. And... especially when you're talking about these kind of shorter range ferry transport type setups, both I think Candela and Navair are working on. They're starting off with kind of more personal size vehicles. So like for a family or a small number of people, but then wanting to work up more towards like ferry vehicles, but that are electric hydrofoils for transporting 50, 100, maybe 150 people at a time. Like if you're going across San Francisco Bay or along coastlines and stuff like that. I love them. I think it makes a ton of sense. You run into some issues if you try and do them really long range for cargo. Volo, whatever how to pronounce their name. They used to be a company called Boundary Layer Technologies that was trying to do large size hydrofoil based cargo ships, but hydrofoils, you still run into that issue of like, even though you're able to go 2 or 3 times faster and it's still very efficient using a hydrofoil at that speed, you still end up burning more fuel than a cargo ship would at its slower speed, but you haven't cut down the total travel time
Yeah.
enough to kind of overcome that switching cost. So like I said, it's very hard to go that much faster while still going through the water. But yeah, no, I
So
think
so are they always going to be small? Small
they'll either be
vehicles?
smaller for very short distances, but if you're doing like one of the things I think could maybe make sense for the hydrofoil based cargo vessels would be one of the concepts I've seen is that we're starting to see designs come out for cargo ships that are so big they cannot fit into any existing port.
So they can't go through the Strait of Hormuz, for example?
Correct. Like, so what they, the way that they, at least this concept that I've seen floated is, pun intended, is that you would have these giant cargo vessels would basically anchor offshore, and then you have a whole bunch of smaller ferry vessels that do trips in and out that can then be offloaded using the normal cranes and systems. And then that big, huge ship just like plots around the ocean, going from port to port, transporting insane amounts of cargo along each trip. And then once you get to the kind of off the port that you want to, then you have a whole bunch of these kind of ferry vessels going in and out to bring in those containers. I have no idea if that system will work, but that would be an interesting situation, because at that point, it's how fast can you move back and forth?
Yeah.
And so if you had kind of a short range hydrofoil, especially if it was electric, because then you're making that process very efficient, very quick, and you can do lots of trips back and forth, transporting like, I don't know, 20 or 40 containers at a time, whatever it comes up being. That could be an interesting use case.
So like a last mile delivery type
Kind
thing.
of. Yeah.
Yeah. Okay. Do you ever think about making it bigger?
Oh, yeah.
Leviathan?
Yeah.
Yeah.
The bigger they get, the more efficient they get and the safer they get, because we can be even higher off the water. In fact, there's a video that just came out recently that I'd actually seen about it, known about it for a long time, but finally a publicly available video. There was one that was on Nebula too. But so Roberto Bartini, who we've kind of focused more on as far as like inspiration for our design and everything, he literally had a design for a ground effect vehicle aircraft carrier. Yeah.
Wow.
Gigantic, huge thing. And it had inside, it had space for something like 20 fighter aircraft. And the whole idea was it would be flying along on the water at the takeoff and landing speed of fighter jets. So they basically like bring them up on an elevator, and then a fighter jet can basically take off vertically off the surface of it because it's already traveling at its takeoff speed.
Yeah.
No idea if it could actually be built that size. Certainly not, like this was a concept that he was throwing around for the Russians. Probably could not have been physically built then, but there's been a bunch of other designs that are much larger, like Boeing. Back in the late 90s and early 2000s, Boeing was playing around with a design for an ultra large cargo ground effect vehicle called the Pelican.
Yeah.
And so to give you some context, our design that we're currently working on, target is 250 tons and be able to carry it. That 250 tons, probably about 5,500 miles. Total design mileage of 7,500 miles. And we probably drop down to about 200 tons for that range.
Okay.
Maximum takeoff weight for the vehicle is probably going to be about 1.2 million pounds. The Pelican that Boeing was playing around with and designing as a potential ultra heavy lift transport for the military, its cargo capacity was 1.5 million pounds. Like that thing made what we are doing look tiny.
Yeah.
And they took it through a decent amount of the design studies, everything, even had some patents involved with having literal shipping containers get stored inside of the wings. The whole front of the whole thing just opened up. It was insane and cool. It looks absurd, but in a fantastic way. Congress didn't end up picking it because they thought it was too big and too ambitious. So Boeing basically shelved it. But yeah, there's been designs of these being able to have cargo capacities of 1,000 tons, 2,000 tons. At that point, it really just becomes a materials and manufacturing problem.
Yeah.
Like how big, like physically big of something can we make that can handle these stresses and forces? Thanks to composites, we can probably get pretty good size ones made. But yeah, once we have the first one of ours flying,
Yeah.
Fully intend to start working on designs for a bigger one while we ramp up production for the small ones.
Yeah. Yeah. Because you can definitely take inspiration from current vessels. I mean, there has to be something in there. Carrying more than 10,000 containers at a time, and you're talking about they're even making the bigger ones now. So there's something there to be learned, I guess.
Yeah, for us, and it's all comes out at that point. It's how big of something can we physically build, and where do we park it?
Well,
yeah.
Well, I mean,
that's one of the limiting factors on what we're designing right now is we're having to keep the wingspan and the length down to a reasonable amount so we can get into the harbors and ports that we want to use.
Yeah, I mean, if you tell someone you can transport goods from Los Angeles to Hawaii in 6 hours maybe?
It's about 7.5.
7.5 hours. Okay. Yeah. And you can transport a lot of it. I'm pretty sure you're gonna have a lot of parking space.
Yeah. No. Well, theoretically, but ultimately, all of the harbors and ports that exist, they're defined sizes. So the entry channels into them.
Yeah.
The two that we want to use, their entry channels are about 400 feet.
Yeah.
And so we're making sure that we keep the wingspan to a maximum of 300 feet.
Yeah.
So we can still get into there to pull up to the docks and harbors that we want to use.
Yeah.
So down the road, maybe it involves us being a big enough company and a big enough entity where we can set up our own terminals and our own harbor areas to interface with even larger size Leviathans. But that's a way down the road opportunity / problem, depending on how you look at it.
So you said the Port of Long Beach?
No, actually the one that we're looking at most in Southern California to potentially operate out of would be the Port of Wainimi. Since we're not using shipping containers, although it will be able to load 20-foot shipping containers, but we don't use cranes to do it. We don't need the cranes. We don't need a deep water channel because the draft of these is only going to be 6 to 8 feet, somewhere in there. Mm-hmm. So we can get into smaller, less used, lower traffic secondary areas.
Yeah.
And our plan is to operate out of either roll-on, roll-off facilities or break bulk facilities. And at least right now, the plan is to basically take old surplus barges, ubiquitous, they're basically just a floating metal box, and convert them into a floating dock interface so that the barge gets moored at the dock and has a ramp connecting to the actual dock, and then the Leviathan pulls up to the other side of it. Everything rolls off of the Leviathan onto the barge, then onto the dock, then immediately goes onto a truck and goes to basically a regular old distribution warehouse inland so that we don't have to build any infrastructure at the harbor or at the port. Yeah. We can use everything that's already existing, that we don't want to have to do any building of stuff. Yeah. And if we need to move or adjust things, we can just move the barge somewhere else. But the nice thing is it means we can use these lower traffic secondary facilities that at least theoretically should be easier for us to operate in and out of and have less congestion.
Yeah, because Southern California ports are congested consistently, whereas the East Coast is open. So if you consider East Coast ports and I know it's a longer route to get to Hawaii, but
it would mean basically going all the way around South America, which though the Drake Strait is not a friendly place.
Yeah.
No, our plan is to for a very long time, we will probably only be playing in the Pacific Ocean.
Yeah.
Mostly because that's just where most of the cargo crosses.
It is.
So there's a huge number of routes. So we'll see if it works out this way. But ideally, we'd want to have Hawaii kind of act as a hub for us in the Pacific and kind of use it as our center point. And then basically eat up all the tonnage traveling between Hawaii and the mainland that makes sense for us going to Southern California, and then just add another endpoint on the other side of it, whether going down to Sydney or going to Tokyo or maybe going to Shenzhen or Taipei. We'll see how those relations are when we're up and running. But there's a whole bunch of possibilities to add on to those, and basically just add on one endpoint, then just every Leviathan we build after that goes onto that route until we've eaten up all the tonnage there, add on another endpoint, eat up all the tonnage there. And that way we can keep our operating like complexity and logistics and costs as low as possible while still adding more and more and more revenue to the system.
Yeah, from a pure demand revenue standpoint, the West Coast is a no-brainer. But from a pure no restrictions, no congestion, easier to reach places type standpoint, going from the East Coast, maybe somewhere in the port of Georgia or somewhere, all the way to some of the Caribbean islands in the Atlantic Ocean, and maybe even to Europe. From there,
Europe potentially, we'd have to probably come in through the Mediterranean, because if you go into the North Sea, which is what you'd have to do if you wanted to get into Rotterdam and some of the other places, that gets a bit sketchy. That said, Africa, I think, is going to be huge in the coming decades for international trade, as it really starts to become a major player in the global economy, to where it could be going from East Coast to Africa, or even connecting Africa to South America. There's some interesting route potentials along there. The other thing too is that because we won't be able to fly over land, we basically have to build them on the ocean we want to use them. So whenever we want to actually start operating on the Atlantic, we'll have to build an entire new production facility on that side to start adding them over there. Which will probably be a ways down the road for us. I think we can turn this into a pretty substantial, successful company, just focusing on the Pacific. It might even be a case to where we eventually get to the Atlantic by going the other way around, just adding more routes, going into kind of South China Sea, then going into the Indian Ocean, then connecting around that way. I don't know. We'll see.
It's always fascinating when what you're trying to do just has so many use cases, so many opportunities, basically.
Yeah, it actually makes it kind of harder to.
It does.
Like focus in on, like, figure out what is that first thing you want to do. Like, should we be going to Puerto Rico, or should we be doing these other things? Should we be building them on the Gulf Coast and going down to Mexico or South America as the first route? We've kind of looked at all those. I think we have the right plan now. Time will tell. Famous saying, everyone's got a plan until they get punched in the face. We'll probably start getting punched in the face here in the next couple of years, so we'll see how that plays out.
Just so you know, right, I think currently the congestion on the West Coast is terrible. It's so bad that if you rerouted a vessel all the way to the East Coast, you'll probably get there and be able to dock and receive whatever you want to receive faster.
Well, and I mean, that's why we don't want to use the main ports. That's why we don't want to go into Port
based on
of
what
LA.
you described.
That's why we don't necessarily want to go to the Port of Long Beach, and more importantly, why we don't want to use the standard container-based facilities. Because if you're going into like either a roll-on, roll-off facility, which is what they usually use for cars and things like that, those are usually much less congested. The same for if we even operate of like more break bulk facilities, just a general like dock area that's not even specialized, that we just need enough space for these to be able to roll off and get loaded onto a truck. And then, because the actual place where we plan to do all of the receiving from customers and the receiving from Leviathans and managing that whole process, we're just going to rent like regular old warehouse space, like kind of as close to the port as we can get, but whatever exists, so that it's basically just a distribution center to where everything goes on a truck to go to the port to get dropped off for the Leviathan when it's leaving, and then everything to get offloaded from that Leviathan just goes immediately onto those same trucks to come back to the distribution center. But it means we don't have to build anything. Like we just rent warehouse space and have trucks do all the loading and unloading at the port, and then we have like a floating dock interface that should be pretty darn cheap to actually like build and implement, because old barges are ubiquitous. That way we keep our footprint very light and keep our expenses very light.
Okay, I like it. Speaking of some other avenue for Leviathan, companies like SpaceX and Blue Origin, they like to position themselves as commercial entities and taking people to space and whatever. But if you worked at SpaceX, you would know it's considered weapons technology. So it's considered like military application. If you're not a US citizen, you can't work there. Do you ever see Leviathan being considered as
Oh.
use in the defense sector for military applications?
Massive amounts. That's actually one of the things we're thinking a whole lot
Oh,
about
okay.
right now. Yeah. Like long term, as far as revenue generation, we think it's going to be a drop in the bucket compared to what's possible on the commercial side. But huge potential for not only DoD applications, but also large amounts of non-dilutive funding, which, yay, we want that.
Yeah.
But no, like literally going to, what is it? A Global Expeditionary Logistics Symposium. I always struggle to remember the name, in early August. And it all to show off like what we have in mind for how Leviathans could benefit military applications. Because there's the basic thing of just like transporting cargo, like from one port to another, or from like a port to an island or a base or whatever. Then there's, hey, it lands on the water. So theoretically, we can resupply ships at sea, submarines at sea, like recrewing, rearming, all these different things. That's one of the issues they're actually running into with like destroyers and cruisers is once those fancy vertical launch missile systems they have that work amazing, once they've launched all their missiles, for them to get back to port, rearm, and get back into the engagement area is like 3.5 weeks. But if we can drop off missiles for a rearm ship, or we even have some ideas for like a floating missile deployment system that would basically just be a floating version of Rapid Dragon, then these could basically deploy an entire destroyer's worth of firepower every 24 hours anywhere in the Pacific Ocean. There's a lot of interesting possibilities that open up when you're able to carry this tonnage at this speed at this range. And since they have such a low draft, theoretically they could even do basically pull up to a beach and have ramps come down when the front of the door is open, and you can roll off Humvees or amphibious fighting vehicles, or like tonnage wise, these will even be able to carry 3 Abrams as well as support vehicles and equipment, all of which you can now just have rolling off. And where it gets really fun to think about is there aren't very many adversaries on a global stage that have really good satellite-based detection systems or AWACS systems. And these fly super close to the surface of the water, but they're not in the water. So sonar can't pick them up. And you're flying so close to the water that most radar systems won't be able to see them until you are very, very close.
Don't give them any ideas now.
Yeah. Oh, yeah. No, I mean, they're not stealth, but they inherently live in one of the hardest sections of airspace to detect things at a range. And if it's traveling at 300 miles an hour and you can only pick it up 20 or maybe 50 miles out, by the time you spotted it, you only have 10 or 15 minutes before you have massive amounts of forces rolling off onto your beach.
I see.
So yeah, there's a lot of really interesting potential use cases for a system like this when it comes to defense applications.
Absolutely. So then to that point, what's the connection between Leviathan and DARPA's Liberty Lifter?
Yeah. That one I'm actually really excited about, because that gives us even more validation. Like I'd already been thinking about this and planning it for about 2 years before any of that came out. But I remember seeing that first like notice come out from DARPA. I was still working on the last company at the time of it. Yeah, that is essentially a DARPA working on making a seaplane ground effect version of the C-17 Globemaster.
Okay.
There's a couple things that they're doing a little bit different. So one of the requirements that they have in it, which we've taken pretty much everything straight from their requirements as far as like sea state size to be able to take off and land, sea state size to be able to operate, target tonnage. We're actually more than doubling the target tonnage. Like the target tonnage is, I think, 100. But one of the requirements they have is for it to be able to fully leave ground effect and fly up to 10,000 feet, I think. Which we have zero interest in never doing that. Like we wouldn't even if that whole process had started now to where we could basically apply and go for that, we still wouldn't be trying to do that, because that entirely changes what the system looks like when it comes to the commercial side for certification and everything. Because now you're talking about something that would need FAA certification. We're also optimizing all of our power systems to be sized for being in hyper efficient ground effect flight as opposed to being out of ground effect. We'll only be able to do that at most temporarily. But no, I think it's an awesome program that they're working on. We'll see if it actually comes to fruition. Aurora, I don't think has actually ever taken anything all the way to production yet. And those type of DARPA programs are notorious for not really ever going anywhere long term. But as far as the concept, like having a 100-ton transport that can do 7,500 miles flying at turboprop speeds, which is what they're doing, makes a ton of sense. It wouldn't make sense to try and make a commercial version of it because based on all the numbers we've run, because one of our hypotheses is that to make it economically viable and to overcome switching costs, we need to be at minimum half the cost of air freight just to get people to make the switch. And if you plug all those numbers in and tonnage and flight time and operating costs per hour and all that stuff, like right at about 100 tons, it's like maybe. You can be in the black, but you can also very easily be in the red if you're just slightly wrong on your operating costs. When you get to 150 tons, it's like, okay, now it's starting to look interesting to where you're kind of in the same operating realm as like a standard air freighter. But once you get to like 200 to 250 tons, now the numbers are like, holy crap, this makes so much sense that we can actually sell this to investors because the margins on it, the returns on it, the possibility for us to be completely wrong by like 2x on our operating costs and still sitting at amazing margins, it makes it that much more compelling, which is kind of why we've sized to where we have.
I see. I started thinking about something just now. This is a vehicle that doesn't exist commercially. And even for companies that go into a new space but present the technology, for companies that get into an existing space and then make something that is slightly different, they have issues with insurance. Are you prepared for that, or are you ready to self-insure if it ever goes that far?
That is one of those that, like, genuinely, we'll see.
We'll see.
Yeah,
okay.
we don't we don't fully know what that's going to look like yet, and at the same time, it's so early for us to even be able to kind of tell what that's going to look like. Again, the nice thing is because we don't have people on board, theoretically, that should make that a lot easier because it's just ensuring the value of the cargo being transported on it.
Yeah.
As opposed to like the value of human life being transported on it, which is a lot different. So we'll have to see how the insurance plays out. There might even be a possibility of that the people doing the shipping are paying part of the insurance for insuring their goods as it's traveling. Yeah, the insurance is going to be interesting to figure out. We don't. That's one of the things that we don't know yet.
Yeah. I mean, many companies have had to just set up their own insurance just because of how the insurance space likes to deal with things they understand, right? Insurance companies, it's a funny anecdote I like to say. Insurance companies don't actually like risk as much as they try to point. You know, anytime there's risk, they walk away.
Yeah, I mean, their whole job is basically avoiding risk at all costs, but trying to profit off it every once in a while.
Exactly. They try to profit off it. Okay. But outside of e-commerce and potentially defense, what other impacts could your tech have in the future? Any other things you're looking at?
I mean, there's some potential things on like transporting fuels, energy transport, stuff like that. I don't know. We'll have to see. That kind of comes down to the size of ones we're able to do in the future, to where you could do more bulk cargo transport. I'm not sure if the numbers will actually make sense on that economically. But I mean, yeah, our real prime focus is like on cargo transport, which is going to be more general cargo, like e-commerce. Yeah, it'll be part of that, and we'll play into that. But it's everything from electronics to equipment to perishable goods, food, frozen food, pharmaceuticals, all that stuff. Like there's a ton of stuff that travels both air freight and ocean freight that we think makes sense on this. And then, the defense side, it's very interesting.
Okay. Fantastic. When is the first Leviathan going to be available?
Our target right now is to have the first one flying, and ideally generating revenue 6 to 7 years from now. If we can do it faster, cool. Some of our advisors think that might be possible. Some of them are saying it's probably going to be a bit longer. It kind of comes down to how smooth the process runs. It does help that what we're doing, not exactly simple and not exactly straightforward, but it's also nowhere near the complexity of building like a 747 or an A380 or anything like that. The way that I usually like to describe this is our operating envelope, which is kind of the entire mapped out set of kind of performance parameters that an aircraft can operating in. Our envelope is the size of a postage stamp. Like we don't do any of this. We don't really do any of this. We just do a little bit of this, and we fly flat, stable, level, smooth, and relatively slow. And that's all we do, but we do it very efficiently, carrying massive amounts of cargo. So as far as like a performance and operational standpoint, the capabilities, it's not near the kind of performance and complexity of a normal, large size jet aircraft. So in theory, that should help us get the first one designed and built reasonably quickly and for a reasonable amount of money.
Here's a crazy idea. Just hear me out. Go to where they park old 747s, right? Get them for cheap. Combine two together.
You're not you're not the first person that's kind of suggested this thing. The problem is I think that would actually be harder and cost more than building something specifically designed for this.
Just to demo it, not because that's the Leviathan or anything.
Oh, yeah. I mean, at that point, like if we're building something that size, we need to have it seriously generating massive amounts of revenue. Be kind of the real thing. But I mean, like smaller size prototypes we'll be able to do pretty easy and pretty quick, especially since we're going to be taking advantage of a lot of technology that's gotten a lot cheaper over the years, especially like on drones and electric vehicles and electric aircraft, just using drop-in components that other companies are building for other use cases that we'll be able to take advantage of. But yeah, the big one to really have it make sense. In most aircraft, they're designed to not operate in ground effect. They're trying to minimize it and get through it as quickly as possible. So they're not optimized for ground effect at all. Also, you run into issues with their power systems, whether it's jet engines or turbo shaft propellers, are all optimized and designed to fly at very high altitudes. That's what they're tuned for. They're not really tuned for like sea level operations for extended periods of time. That's kind of one of the reasons that I like helicopter engines a lot more, is because most helicopters only fly a couple thousand feet up. So their engines are tuned for much lower altitude operations. Like it's one of those things. Had a few people suggest that, thought about it. I'm not sure if it would actually be any easier, and we'd end up with an inferior product. Yeah,
it's probably better and cheaper to just build smaller prototypes and then build eventual big ones 6 to 7 years from now. Speaking of one issue that I've seen, I've read about when it comes to ground effect vehicles, cavitation, rusting, and things like that. Can you clear up how your Leviathans would avoid that?
Well, on cavitation, are you talking about with hydrofoils, or because when cavitation is what happens when you have like you're traveling through water. It's usually on propellers or on the hydrofoil surfaces itself, to where you generate so much negative pressure that the actual water vaporizes and turns into.
So that only happens when you come in contact with water itself?
Yes.
Okay.
Yeah. Which we will have to worry about that with the hydrofoils for takeoff. That's why one of the things that is kind of one of our core design criteria is to have our takeoff speed. It's actually one of the things that's most challenging about the designs we're working on, is to have our takeoff speed be roughly 60 knots, because that's about the maximum speed that you can go with a hydrofoil. Because we need those, like we're going up in speed with the hydrofoils, and then we need to make sure that we overlap with the aerodynamic system, so that we can basically transition the load from the hydrofoils to the wings and then just retract the hydrofoils. But those speeds have to overlap, otherwise we can't get there. So that is something we'll have to worry about with the hydrofoils and maybe with the propellers if we're using those to like offset drag forces. But corrosion is something we're absolutely going to have to worry about. And that is almost entirely going to come down to using massive amounts of composites, using marine grade aluminum, which is probably what the lower hull is going to be made out of, just welded 5000 series aluminum. Very corrosion resistant, also very tough for impacts and stuff like that. Probably lots of stainless steel, although we have to take into account for like galvanic corrosion, stuff like that. Maybe even titanium, because that's starting to get easier to do if we're 3D printing it, which can maximize like the value we get out of those parts. And there are a lot of material coatings. Like we're just going to coat everything in plastic.
Yeah. Speaking of 3D printing, there are companies that 3D print very large objects now, right? So
yeah.
So that should be a good thing. Okay. Yeah, it's just when you're talking about water, it's a blessing and a curse. You have these issues that you're gonna have to deal with. Also, along with the fact that it's the reason why you guys are gonna take off really quickly. So, what are the next steps from now till 6-7 years?
Yeah, I mean, we're doing our first round of fundraising right now so that we can start building some smaller scale prototypes and really doing the hardcore computational fluid dynamics to finalize our prototype configuration. Like that's just like high powered compute is just expensive.
Yeah.
Whether you're renting it from somebody else or buying the machines yourself and running it in house. Build smaller scale prototypes, design a larger scale full demonstrator prototype, get that one built. Maybe do another one past that as kind of a medium scale one. If we can make some sort of use case make sense for that one. We're still playing around with that. And then it's really start working on a lot of the subsystems. So like get one of the turbo shaft engines we're going to use, hook it up to a generator, start generating power, have that drive the number of electric ducted fans that engine is going to be responsible for driving. Have that whole thing built out. Because then if we've got that figured out, it's literally just copy and paste to add it into the full size one. Then it's do the flight systems and the flight surfaces and flight controls. And then it's communications and navigation and start building the individual like components of it. So large carbon fiber panels and wing sections, basically doing all of the smaller scale steps involved with building the full scale one, trying to push scaled down or simplified versions of those as far left on the timeline as we can, so that we can get all those things figured out quickly and low cost and do quick iteration on them if there's any issues. And then so that by the time it comes to build the first full size one, we're more so just doing a big assembly process as opposed to having to like do all of it from scratch.
Okay. Sounds very solid. All right. Well, 6 or 7 years time, I would like to see one of these on the above water, transporting something or some things. Speaking of steps, you talked about starting your company, your first company in college, and then you started Accelerate 3D. You built that, you wound that down, and then immediately you jumped into Leviathan. So, is this how it usually works, or do you think that if you're a serial founder like you, that you should take some time before getting into the new venture, or is it just getting next one?
I have no idea how normal people should try and do this. So for me, it was a very different, like a unique situation that I had already been kind of thinking about this. So the way I describe it is this started off as a curiosity, and then it turned literally from watching a YouTube video. So there's a video put out 4 years ago by a YouTube channel called Mustard that's all about the Caspian Sea monster. And it was one of those things that I watched that just because the nerd that I am, that's what I do in my free time is watch aerospace videos. And it was very much why don't we have these now? Because the physics makes sense, the efficiency makes sense, and just kind of started thinking about it. So it started off as a curiosity, turned into an interest, slowly started to turn into like a passion. And now in the last, like since started it full as a company, it's like an outright obsession. But it was kind of like having a song stuck in your head. To where it's just always kind of there. And whenever you weren't actively thinking, when I wasn't actively thinking about or working on Accelerate 3D, I would see like, oh, distributed electric propulsion systems. This is interesting. Oh, you could use this for the ground effect vehicles to make them that much more efficient. Oh, this other thing, you could use that. And it was just kind of seeing all these pieces over the years and kind of building it up in my head, to where I pretty much had it not like fully figured out, but it like had enough to where I was like, it's at least plausible that this would work. And then of course you start thinking about like, okay, how would you interface with ports and who would the customers be and things like that. And so by the time it came apparent that we needed to wind down Accelerate 3D, I already had this pretty well baked. And that was kind of when I knew that it was fully time to wind down Accelerate 3D, because I found myself just wanting to think more and more about Leviathan and not wanting to think about or deal with Accelerate 3D. And I mean, that combined with the fact that like VCs were viscerally disinterested in 3D printing, I was like, okay, probably time to call it on this. And so kind of immediately jumped into this, but like I spent the first 2 or 3 months, like I was like, I want to make sure that I'm not wasting my time on this, because could be argued that I wasted time on Accelerate 3D, that maybe should have stopped that earlier or maybe not done it from the beginning.
Hindsight's 2020, huh?
Yeah, it always is. It's kind of annoying. But so I spent the first 2 or 3 months just meeting with all of the best aerospace people that I either knew or get connected with to try and get them to convince me that this was a stupid idea. Because I was hoping that they would say like, no, this is not going to work, or there's this problem, or these issues. Why don't you know this? You're a dummy. Don't do this. And instead, 2 of those people are now on our advisory board, and the third one's my co-founder, because all of them, like people who knew way more about aerospace than I ever will, were all like, yes, these things need to exist. There's no reason that they shouldn't exist.
Yeah.
It just comes down to like scale and resources and actually somebody taking the risk to make it happen. But the physics is sound. The aerodynamics is more than sound. And it's been something people have been obsessed about for years. It just hasn't been the combination of technologies available to make it really, truly viable, and someone to actually take the risk of starting the company to do it. Because like Boeing, Airbus, Lockheed, they don't take big, huge risks anymore. Like that's the only way that this would be made, like traditionally, is if one of them actually took a risk and made this happen. So it has to be someone who knows that ground effect exists and then sees the potential of it to exist today, which that's a small set of people know about ground effect vehicles. A small set of those recognize its potential today. An even smaller percentage of those people would be willing to actually think that they can start a company to actually build these and make it happen. An even smaller percentage of those people are crazy enough to actually take the shot and do it. So apparently I'm that small percent of a small percent of a small percent of a small percent. And so I just went out and started talking to all these people, and all of them were like, yes, let's do this. Let's make it happen. And it kind of, I remember sitting down after talking to one of our like main advisors now, and he, within a minute of me talking about it, he's like, oh, so you're doing large size versions of what the Russians were doing. That's awesome that you even know those exist. Needs to exist. There's no reason they shouldn't exist. I'm not looking for a new job, but I can help out. I can advise. I can do all these other things. Like immediately started offering all this stuff. And I remember walking out afterwards, because that had been plan B, was, oh, would you maybe be interested in being an advisor? And I walked out afterwards. I was like, all right, I guess I got to do it now. Okay, cool.
Yeah.
And now I've kind of forgotten even what the question was.
Explain why the transition was so quick.
But because I already had it like ready to go and just immediately dove into it. I don't think that's how most people would probably do when they like are having to wind down something they were working on for 6 or 7 years, is how long I was working on Accelerate 3D. And it was a transition period. It was like a few months of winding it down and going through that whole process, and then kind of starting to ramp up on this. But the more that I started to work on it, and the more that it just felt like it was working, like I've described this a bunch of times. It's the best way I've thought about it is that with the last company, for every unit of result that I was getting, it felt like I was having to put in like 10 units of effort just to move the needle a little bit. With this one, it's like 1 unit of effort, or maybe a half unit of effort, gets a unit result.
Yeah.
Like it feels
Difference.
like it just wants to happen. Like that other people want this to happen, and people are
Yeah.
excited to help make it happen and be involved and help out and work on it. And that makes it very exciting and easy to be passionate about it and want to work on it.
Yeah.
When it not only is it like a ridiculously cool solution and a huge market and a huge space that there aren't very many other people like working on this right now, but the fact that it just feels like it wants to exist and become a thing makes it so easy to be super excited about it.
Yeah.
And that was kind of that building up that process of taking those first few steps and being like, oh, this feels like it's working. And you take a few more steps, it's like, okay, this definitely feels like, and the more it kept going along, the better and better it like felt like it was progressing. To where in just the last 10 months of working on this, I think I've made more progress than in the first 5 years of working on the last company. Like pretty much the only thing I don't have is just a working prototype of this thing, because that doesn't make sense at this point yet. But everything else, as far as pulling team together, getting people excited about it, having like other interesting serendipitous things play out. Yeah. Like it just kind of started to pull itself into existence, and I'm just trying to keep up.
Sounds really interesting. What you're going through and what you just described about the 10x effort versus 10-to-1 ratio in terms of effort and reward for your previous company, whereas it's the reverse in this case, reminds me of an analogy I always like to give to people who ask business advice from me all the time. They're like, I have this idea. So I talk to a bunch of people and they're like, wow, your idea is so wonderful. You should do it. It's so good. And that's all they say. And I ask them, did you try to sell them the product? They're like, yeah. They said it was just a good idea, but they didn't buy the product, did they? So what's happening to you is what should happen when you have a very good idea and when you have something really good going on, is that you tell people, I have something for sale. And then instead of saying, wow, that's so wonderful, I'm sure someone else will buy it, they go ahead and place an order immediately. And then when you have you don't have a product to offer, like in your case yet,
they start putting in effort.
They start putting in effort instead of saying, wow, that's so wonderful. I can't wait to see this work.
How can I help? I want to be involved. Like and start like doing work and putting in solid things. Yeah. No, that's 1,000% agree.
It's a metric that a lot of people miss. They get stuck on praises and people making them feel happy instead of people actually providing tangible inputs into what they're trying to do. And that's really the validation you need.
And especially at this early starting point, we're starting to talk to freight forwarders. We're starting to talk to potential customers, trying to turn those into like LOIs and stuff, but we're still so early. It's almost like too abstract for some people to fully understand. But the fact that we have very, very high talent, high caliber people wanting to be involved in this and put in effort, that's kind of what I've been viewing mostly as our kind of early traction metrics, is that people are excited about this and being actively involved and putting in effort, who understand all of these different aspects, whether on the logistics side or the aerospace side or whatever. They all look at this and are like, oh, not only do I think that's a cool, good idea, I want to actively help build it. And
I can see a situation in which you're getting interns working for free. You're having early stage employees being like, just give me equity, I'm cool. And just making it easier for you to, move fast without being bogged down by expenses and, things like that.
I think it'll also help us a whole lot in acquiring talent. Talent is, because this is one of those things that is just ridiculously cool. Like it's a flying cargo ship. That's just cool. Like, you could go build the next 50th flying taxi or whatever, or other things that are being worked on, or you can come help make flying cargo ships a reality. It's like you can picture them, you can see them, like what it would look like flying across the surface of the ocean, and it's just gonna look so cool. I think that's going to be really helpful for us when it comes to scaling up the team, of being able to sell people on that vision and just have, because pretty much every engineer like that I've talked to or gotten to know talked about this has been just like, okay, this is very cool. This would be something fun to work on. And I'm like, I know. I'll keep you in mind.
To that point, where can people find you? if they want to work with work at Leviathan or on Leviathans, and just anybody, how can they reach you?
Yeah, I mean, we have a website, leviathan-air.com. There's not much there right now because we haven't put much effort into it yet. I should probably get on that. YouTube, we have like a really, really cool video that shows the concept and the process and everything and what we kind of view this being. Probably just search Leviathan Air and you'll find it. I'm on Twitter/X, whatever it is now. God, that's so annoying. Pretty active on there. Pretty recently on getting back onto that.
Yeah.
Life of Riley ATX, I think is my handle on that.
Yeah.
Those are usually the best place. And LinkedIn, just hit me up, Riley Knox.
Yeah.
Very active on that too. Most people just reach out directly, and yeah, love talking with anyone who's interested in helping us turn this what seems like a crazy big huge moonshot idea, even though it's like not compared to when you're looking at like people are building fission reactors and fusion reactors and launching rockets into space and making hypersonic jet aircraft. Like compared to that, what we're doing is not some crazy moonshot. It's just like big and ambitious. So yeah, anyone who's interested in being involved or helping out or just geeking out about aerospace stuff, I'm always down to talk to.
Yeah. Cool. Thanks for coming on the podcast again, Riley. It's been fun to have you on a second time.
No, yeah. And thank you for putting this on. I think I might have even said this last time. The fact that there is like a pure hard tech and deep tech focused podcast is awesome. Like I love listening to all the other people you've had on board. It also helps that I know a decent number of them because it's kind of a small community. So every once in a while I'll pop up on my feed like, oh, Kobe or oh, somebody else be on talking about stuff. And thanks for like just having this be a thing, because I think we need one of the things that's really starting to become apparent, not just like on the concept, but even when you look at like VC money and everything, is that I think a lot of people are starting to realize that we're approaching the end of what you can do with pure only working on software.
Yes.
That we're kind of getting to the point at some point, if you want really new things to exist, you just have to build new hardware to run it.
Yes.
You can only do so much with software before you need new things to do the new things.
Yeah.
And I think we're really starting to see that with a large push in deep tech and hard tech investments, especially on DoD side, that people are realizing, one, we just need new things, like new physical systems to do these more advanced tasks and capabilities. But then when also you're looking like, oh, are we going to lose access to like the manufacturing bases that we've built all of our systems around for the last 30 or 40 years? How much are we going to have to pull back here to the US and redo that type of stuff? So having someone actively talking about that side of startup world is awesome. And I love seeing that.
Thank you, man. Really appreciate it.
Yeah, no, there needs to be more. So keep going, keep doing more.
All right. Thank you once again. If you enjoyed this episode, please consider supporting our mission of providing good quality content and conversations from within the hardware tech space. And all you have to do is like the video, share it with your friends, and subscribe to the channel. Thank you for watching.